This
I can
conference
continue.
will now be recorded.
Yes, sir. Yeah. Okay. This is my basic study for introduce the criteria of morphomathematical investigation for groundwater recharge, how the structures is constructed on behalf of this morphomathematical investigation. My study consists for the micro watershed that is known as Paneer micro watershed or Paneer river basin. The morphometric parameters which Paneer river basin, I have studied this hydrological and morphological actor region. Study the aims of the study the morphological actor and Paneer micro basin of watershed. The area of investigation lie in the Madhya Pradesh, northern Madhya Pradesh, and it is 99.5 square kilometer, speed in 99.5 square kilometer, Paneer river basin. Mainly the geology of this area is covered by Archeans, namely known as Bundelkhand granites, granitoid rocks. These granites are introduced by various quartz reef and dolerite dikes. The general trend of these intrusions are north-northeast, south-southwest, and southeast southwest. Mathematical analysis has been carried out to understand the geometry of the drainage basin, drainage network, and drainage texture. This is the location map of the my study area. This longitude by latitude and the village location. Then we come to material and methods. Morphomathematical investigation of Paneer have been carried out on a survey of India toposheet number 54 PY6 on the scale of 1:50,000 square kilometer. First of all, the perimeter of this also demarcated on the toposheet by Stahler's method, and various length of the stream has been measured by rotameter, and the area of Paneer river drainage basin measured by using planimeter. All the morphomathematical parameters have been computed using standard formulas, standard equations described by various previous workers and shown in table 1. So this I have taken these parameters for this morphomathematical investigation. Particularly on the basis of this bifurcation ratio, I have calculated form factor, basin circulatory, basin elongation, lemniscates, drainage density, and drainage intensity. So these are the standard formulas which are given by previous workers. On the basis of this formula, I have calculated all these parameters which are used for the construction of artificial recharge structures, particularly stop dam, chap dam, underground dikes in a particular under the people's participation in Rajiv Gandhi watershed mission of Chhatarpur district. Next, come to result and discussion. Drainage morphomathematical parameters understand the hydrological and morphological character of a basin or a watershed or a micro watershed, useful to understand the lithological and the geological control. So all these parameters of this Paneer river micro basin or the watershed has been described in following manners. So first of all these morphomathematical parameters are divided into linear property. Under linear property, first of all, I should calculate the stream order. Stream order map have been prepared on the basis of Stahler's method. Stahler's gave a method on 1957, and the maps are shown in figure 2. It is on the basis of stream ordering. The Paneer river is a fifth order stream. Then computed stream length in according to Horton's 1945. The stream length has been counted and found that there is a progressive decrease in a number of streams as the numerical value start order increase. First order is the maximum length, and the fifth order increase. Graphical representation of these of semi-log paper do not yield or a perfect straight line. These departure suggests that the presence of some sort of slightly complexity in the resistance of the rock of the study area. Particularly this the rocks of the Bundelkhand granites or granitoid rocks, which are Archean, older than Archeans. So they have the textural variation and the mineralogical variation, and then color variation. On the basis of this, particularly one outcrop showing the different structures and textures in color variation. So on the basis of this stream numbers, where the weathered portion of the granites more, the number of streams are developed in particular in this area. So this is the drainage map of the area. Particularly this drainage shows that a typical dendritic pattern drainage of this area, and those particular the sickle shape drainage, which is the very good characteristics of the granites. It's developed on granitic country rocks. All these are the sickle shaped drainage. So particularly for this, I have prepared the drainage map of the micro watershed of the Paneer River basin. So this next, this is the stream ordering map of the Paneer River. On the basis of this stream law of Stallers, the stream ordering maps have been prepared. So the Paneer, the main stream is the fifth order streams, and the linear properties of the Paneer River basin is shown here. Stream order first, number of stream 144, second order 36, third order 12, fourth order, third and fifth order 1. This is the bifurcation ratio between first and second. Is it 4? Second and third is it 3? 3 and fourth is 4. 4 and fifth is it 3. Average bifurcation ratio is 3.5. Length ratio and average length also calculated. This is the graphical semi-log plot of the stream order versus number of streams. So all the points are not in a straight line. So there is some slight variation in the underground lithology. Then next come to linear property, stream length. The stream length ratio have been prepared and is shown in the next table. On the basis of this stream order versus stream length, a graph semi-log plot have been prepared. This also shows that there is no perfect straight line. It shows that there is a complexity in structure and lithology, underground rocks. Next come to aerial property. The aerial property is also calculated by various previous workers on the basin area, and basin length have been calculated, basin parameter have been calculated and given in table 3. So basin area is 81.5 square kilometer, basin length is 11.5, basin breadth is 7.5, basin parameter is 38 kilometers, factor 61, circularity ratio, and so on. So form factor, it is calculated by the Stallers method. It is the value of form factor is 0.61. It is a rectangular basin or nearly circular basin. It shows nearly elongated or circular. Basin circularity there. Basin circularity ratio is 0.7. It is 0.70, which indicates the value of nearly circularity. Basin elongation ratio. It is also calculated, and Lemniscate also calculated. It is Lemniscate value, so 0.98 is revealed that the basin under study are nearly circular. On the basis of shape parameter, it is concluded that the Paneer microbasin can be classified as elongated basin. Drainage nature. So under the drainage nature, there is a two type: drainage density and drainage frequency map have been prepared on the basis of this various workers. Drainage density, drainage map. The drainage density is 1.6 kilometer per square kilometer, and the class is divided into very coarse, moderate, fine, very fine, and fine. Fine and very fine. So then the texture of Paneer River basin has been determined, and found the Paneer River basin has very coarse texture. The very coarse texture due to the because the weathering of the granites is very much severe in particular area where the first order streams developed. This is the drainage density map of the Paneer River Basin. I have divided into class 0 to 2 kilometer per square kilometer, 2 to 4 kilometer per square kilometer, 4 to 6 square kilometer. Drainage and stream frequency map also prepared, and this is divided into 0 to 2 streams per square kilometer. Number of streams 2 to 4, 4 to 6, and 6 to 8. So the on the conclude, I am concluding my keynote talk. Morphometric analysis have huge potential to tell the hydrological morphological character of any particular river basin. Conclude that morphometric characteristics any region can successfully rebuild that hydrology and morphological characters. Okay, thank you. So this is a very preliminary study I have done under the aegis of Rajiv Gandhi watershed mission for a particular panchayat area. They have the facing the problem of the overall surface water as well as groundwater. On the basis of this study, I have suggest check dam and stop dam for a particular area. The villagers have the water for a long time. Particularly this Bundelkhand area is under scarcity of rainfall. There is no there is a cyclic variation in rainfall. Particularly 1 year is a deficit, another year there is a increase in rainfall. So this type of study I have done under the aegis of the Rajiv Gandhi watershed mission for the construction of the artificial recharge structure on the demand of the Panchayat department. Okay.
Thank you, sir. So you can answer some of the questions in the chat box.
Okay.
If anyone has any question, please ask. Is there any question?
So Ranjit plate is not there, but our play will start in 10 minutes. And then 9:30. So
any questions, any suggestions for this my micro watershed study?
yes, sir. I think Dr. Om Prakash Rao, sir, can you ask one question, sir? No. Any clarification? Okay, sir. Then, sir. Okay, sir. Thank you, sir.
I am thankful to all the organizing committee of this P.K. Rai Memorial College for the giving me opportunity to sharing a talk on this mathematical investigation and then the today's international webinar. I am very much thankful. Okay, thank you.
Thank you, sir. We will wait for Ranjit Nayak for 5 minutes.
Okay, okay. Thank you, madam.
I think there is some network problem in Ranjit Naik sir. I think they are not able to join. But I'll start my presentation. Hey, just ये करो.
Moving ahead, I would like to invite our next keynote speaker, Dr. Sagar Kumar, who has made tremendous contribution in our field of geology. For his efforts, some of our seniors have got admitted to IIT, IISER, NIT, and various universities. Sir, I would request you to please start the session on concept-based exploration versus detection-based exploration, its application to gold deposits.
Thank you, Ananya, for such nice compliments. Okay, thank you. Then I'll share my screen. Okay. Okay. This topic name is concept-based exploration versus detection-based exploration. Its application to gold deposits in India. Then I think I have 40 minutes of time, so that Ranjit Naik is not Professor Ranjit Naik is not available to talk, so that I will talk for 30 to 40 minutes. What is the meaning of concept-based exploration versus detection-based exploration? From this topic, you will see what is the meaning of exploration, then what are the concept behind this exploration, and there are three terms here used. Exploration. In exploration, what are the different concept-based, and another one is detection-based. Here, what I am mainly focusing on concept-based approach. And in detection-based approach, what means any instrument we can detect minerals, then you can tell on this instrument from this instrument, from this instrumental technique, we'll get the data of this and that. But that is not the case. That is only limited to certain depth, certain dimensions. But with concept-based, we can go unlimited depth. We can suppose, for example, polar gold deposit. For polar gold deposit, that British people came and they have explored. When they have left, I think presently there is no working mines in polar. This is what they have done. At time they have done very nice things, but after then that has already closed. But that gold concentration is there, but we are unable to do. Due to political condition, mainly we have some not that much modern technique to explore. That is what we are something lagging behind. That is what this topic name is concept-based exploration versus detection-based exploration. Mainly, we are giving importance to detection-based rather than concept-based. That is what we are feeling something gap in exploration. Then before going to next slide, then I'm going. First, we will have to work conversion of anomalies into mines. How we can convert these anomalies into mines? First thing, lack of concept-based exploration rather than detection-based approach. Something we are mainly focusing on detection-based rather than concept-based. First, if we'll give importance to concept-based, I think somehow detection that exploration will grow on in great way. Then the next point is it structurally controlled or lithological controlled? Mainly gold, we will have to see many people have many different concepts. Some people have told this is controlled by this lithology or this rock type, that whole rock type that carry the gold deposits. And some people have told this due to this for along the fault fracture or shear zone, that fluid, that secondary fluid, whatever this, either low temperature fluid or hydrothermal fluid, low temperature or high temperature fluid, that will transport this gold from this deeper depth to upper depth. That is what we have different conceptions in this. That means either is it structurally controlled or lithological control. First, we'll have to sure that either this is lithology. Through lithology, that gold is being transported from this deeper depths, or through structurally, or either fault or along the fault or fracture, that primary or secondary, then generally secondary fluid that will carry the gold from this deeper part to upper part. And in always in many cases, that lithologies have been targeted for gold deposits. What is the case? Which if lithologies have been targeted, then whatever, suppose if we'll get some granite terrain, then lithologies always have been targeted for this gold deposit. Suppose if we will have mafic volcanic rocks, then if suppose whole mafic volcanic rocks if we will extract, then there is some if we will get gold around 3 to 4 gram of ton, and we have lots of many mafic volcanic rocks, and we are getting this 1-2 gram per ton. If we'll extract from this mafic volcanic rocks, it will very difficult to extract, as this rock is always hard and compact. So firstly we will have to sure either it is structurally, if that is structurally controlled, we will only extract the gold from this fault, fracture or shear zone, not that whole lithology we can target and we can extract all this rock type. That is what there are different concepts. First we'll have to clear about the either it is structurally controlled or lithological controlled. The next point is your district and regional structural concepts are not used in exploration strategy. So first we'll have to see, suppose in there are 5 different cratons in India, such as Dharar Craton, then Aravalli, then Bastar Craton, then Bastar Craton, Aravalli, Dharwar. Then there are almost 5 different cratons. That is what if we'll see that in different cratons, that is what we'll have to see. Means in the one craton, if we'll focus, what are the different structures of the fault? Many major faults and minor faults, yeah, major fracture, yeah, minor fractures, deep-seated fracture, yeah, deep-seated fault is there. First, we'll have to locate in craton. That is what from regional, yeah, from district to regional, which is from regional to detailed scale. That is what we will have to see. That is in Dharal craton, how many major, yeah, major deep-seated faults are there. First, we'll have to see in region, which in large scale, then we will have to come in detail. That means in small case, suppose you'll see this Jonagiri Gada cold field, then we will see what is the strike of that fault, yes, your zone, along which the gold is coming out. But still there is contradiction in that. Some people are telling this is lithological control, and some people are telling this is structurally controlled. That is what we'll have to clear, either it is lithological control or structurally controlled. Then the deposits on the surface are already exerted. If you see in the India, that already in surface almost that deposit have already existed, and we'll have to go for this subsurface deposit. What are the deposits present below the surface? Then we'll have to search that. As already we have on the surface, already we have got existed, so that we'll have to go below the surface. We'll have to search below the surface. But this is the main things in which we will have to convert these anomalies into mines. Then only we will have to successfully explore the mineral, yeah, these ore minerals. Then before going to exploration, first we will have to see what is the different concepts that are being used in exploration. If we'll see, that is one is syngenetic, epigenetic deposit, then hypogene deposit, then supergene deposit. What is the meaning of syngenetic? Syngenetic means that is what different concept is used in exploration. If I'll not tell these things, then I can go. We can't go. I can't go that. This is what this is the concept what we are using in exploration. Before going to exploration, this is these terms related to your ore deposits. First one is syngenetic, that is the ore deposits that formed at the same time as their host rocks. If suppose any ore deposits that will form at the same time, means if that host rock will carry the gold from deeper to upper, then that is called as at the same time that ore deposit and this host rock have been formed. Then epigenetic, what is the meaning of epigenetic? That is what deposits that formed after their host rocks. If suppose host rocks have already formed and these ore deposits formed after that, that is called as epigenetic. The next term is that in epigenetic there is what, there is your structurally controlled or mainly, or if that magmatic fluid also, that is also that requires also fluid pathways. For fluid pathways that requires also some deep-seated fault fracture. That is what, if deep-seated fault fracture, that the fluid will come out, then that is called as structurally controlled. Then next term is hypogene. What is the meaning of hypogene? One is this mineralization due to ascending hydrothermal solutions. If that secondary fluid or low temperature fluid such as cornet water or meteoric fluid, if that will carry the fluid along the fault fracture from deeper part to upper part, that is called as ascending hydrothermal solution. And another one is supergene enrichment process. In supergene enrichment, what this mineralization mainly through descending solution. Suppose we have pyrite, we have different sulfide minerals. If that different sulfide minerals, if that will get contacted with the rainwater, then FeS2, suppose pyrite is FeS2, then water H2O, if that will get FeS2 reacted with H2O, then that will give your H2SO plus Fe. So if that iron will go below through this water, then this is called as, from this iron will go from the surface to deeper part through this rainwater. That is called as supergene. That is what descending solutions. And another one is ascending solutions. That is based on that, one is hypogene, another one is supergene. Then if we see that epithermal deposits, one is termed epithermal, then mesothermal, another one is hypothermal. If we get this concept clear, then I think if we'll go to exploration, then I think that everything will get clear. Then epithermal, mesothermal, then hypothermal. In epithermal deposit, what? This is mainly formed at shallow depths. Near the surface, we'll get this epithermal deposits, that is less than 1500 meters or at lower temperature. Generally, this low temperature bearing fluid that will carry this any ore minerals from deeper part to upper part. That is the temperature between this 50 to 200 and 1.5 kilo, means 1500 meters only, less than 1500 meters from the surface. Then mesothermal, what is the meaning of mesothermal? These hydrothermal deposits that formed at intermediate depths. That means 1500 meters to 4500 meters, and temperature is 200 to 400. Means if epithermal, that will form at the surface, and if it will go below the surface, that mesothermal. That means 1.5 to 4.5 kilometers. If it will form in kilometers, that will 1.5 to 4.5 kilometers below the surface, and temperature is 200 to 400 degree temperatures. Then if we call hypothermal deposits, that will form at great depth, that is greater than 4.5 kilometers and at elevated temperature of 400 to 600, and also your temperature is more and depth is more, and that is called as hypothermal deposits. Then if we come to source of ore fluid, as for ore minerals to get deposits, there are different source. Either it is low temperature fluid or it is high temperature fluid. In low temperature fluid, there is seawater, meteoric water, cornet water. If we'll go for high temperature fluid, that is metamorphic water, then magmatic water, then juvenile water. And there are 6 different types of fluids. One is low temperature, another one is high temperature. And we'll differentiate all these 6 based on this temperature and salinity. If there is seawater, if that seawater will go below the surface, and again that will carry this any ore minerals from deeper to upper part through this seawater, that is called as this ore deposits formed by seawater. And meteoric water, if that condition is low temperature and low saline, seawater is always high saline, that is what low temperature and high saline in nature, then we will go for meteoric water, that is what low temperature and low saline in nature. And cornet water, if that is also low temperature and high salinity, if any basins that sediments will get deposited, again this through this water, if will go below, then this water will go below, and due to high temperature and some pressure and temperature, again that will come to the upper surface along fracture or shear. then that is called as this ore deposits formed by connate water. Then metamorphic water. In metamorphic water also will get this high temperature and low saline in nature. That is generally formed at the your generally tectonic settings. That is what during subduction, if that fluid will get dissolved, that fluid will get melt, and that will this granitic fluid, any water bearing fluid, if that carries this gold from this gold, any other ore minerals from deeper part to upper part, that is called as through metamorphic fluid. That is found that fluid is generally coming out from the subduction or anything with high temperature and high pressure. If that water bearing minerals, if that will get melt, and that will carry the fluid from below to upper part, that is called as generally metamorphic water. Then if we go for magmatic water, that is what a high temperature and variable salinity. This magmatic water generally come from the subduction zone. If that carries during tectonic activity, either subduction or extensional activities, during that time, if that fluid come out below the surface, and that carries this different gold deposits, different ore minerals from deeper part to upper part, that is called as this magmatic fluid, magmatic source. If that is juvenile source, that is what we are getting this diamond and this different carbonatite deposits. That is what generally this juvenile fluid that carries this diamond or gold also. Also, we people are telling this gold is coming from the juvenile origin along the deep-seated fault fracture. That may be in that case, I will get this high temperature and low saline in nature. That is what different fluids that carries this ore minerals. Then you will see these are the different fluids, and these are the different hydrothermal ore deposits. If we'll see that in the surface, if we'll see this is groundwater in the surface. Then if we'll go below the surface, groundwater in the surface, groundwater seawater. Then if we'll go below the surface, that is meteoric water. If we'll again go below the surface, that is connate water. Then the deeper part, metamorphic water. Again, if we'll go deposit, then magmatic water. Means when we'll go to deeper the depth, that fluid, that low temperature fluid to high temperature fluid. If we'll see this low temperature fluid is the groundwater seawater. Then if we'll increase the temperature, then meteoric fluid. Then again, if that temperature will increase, depth will increase, that is connate water. Then if again the temperature, depth will increase, that is metamorphic water. Like that, some temperatures increase in temperature, like that different fluids that will carry the different ore minerals. If that high temperature fluid will carry the there's magmatic water or metamorphic or any juvenile fluid also, that is also what that orogenic, different orogenic gold deposits that will be formed by this magmatic or juvenile origin. That is what this requires some high temperature bearing fluid. And if we'll go for low temperature fluid, here it is written tin and tungsten deposits, skarn deposits, porphyry deposits, that will generally formed by magmatic water. Then if we'll go for metamorphic water also, and also there are different ore deposits formed. This is also same skarn deposit, porphyry deposit. That is also, if then also if we'll go for connate water, then also here epigenetic gold quartz pebble conglomerate in wheat water stands deposits. That is what found by this connate water. That means what the different people have suggested. Like that, if that is meteoric water or groundwater also, you will get this stratiform deposit, Zambian copper belt like. Then epithermal deposits. Then if we'll go for meteoric groundwater, then we'll get this sandstone hosted superficial uranium deposit. General what are the uranium, what are the different uranium minerals are formed due to this also, that is sandstone hosted, that is generally placer, what we are called as placer deposits also. Then also if we'll see also that a volcanic massive sulfide or sedimentary exhalative deposit, that is also in Europe or Cyprus. We are getting this VMS or SIDEX type deposit in this area. This is also formed by this mixing of both low temperature or high temperature. You see, always there is mixing of this low temperature and high temperature. high temperature fluid. If any high temperature fluid, if any high temperature fluid come below the surface, obviously that will mix with some low temperature bearing fluid. But that fluid ratio is more. That suppose if that fluid ratio is more from high temperature, means a deeper depth, that should be counted as this high. This ore deposits have been formed due to this high temperature bearing fluid. And then this is what we have get clear concept in what are the different fluids that carries these ore minerals from deeper part to upper part here. Then if we'll go for exploration, in generally this is in India we are using this recognition regional survey, then preliminary prospecting, then preliminary exploration, then detailed exploration. There are 4 stages in exploration. First we'll go for this recognition survey, then preliminary prospecting, then exploration stage, then detailed exploration stage. In exploration only we'll have to decrease the area. That is what our main aim of this exploration. First we'll have to go for large scale area, then we'll have to come for detailed scale area. That is what with the exploration, with the help of different stages of exploration, that surface area will get decreased. That is what from region first we'll start in large area. That is what recognition survey will start. Then we'll go for preliminary prospecting. Means prospecting in search of mineral deposits. That is what second stage. In prospecting, then we'll have to decrease the area. Again, if we'll go for preliminary exploration, again we'll decrease the area. And if we'll see the detailed exploration, again the area will be limited to certain distance. That is what if we'll go for large area, then that we'll have to invest more and more. If we'll invest more and also if we cannot get means economic benefit from that, then why we have invested? That is where the exploration. That some economic value is there. If we'll buy something in 2 rupees, then if we'll sell in 4 rupees, then we'll get some benefit from that. Exploration is like that. If we'll invest 2 rupees, if that will not give, if we'll sell in 4 rupees, then that 2 rupees will get economic benefit. That is what called as exploration. If we don't have economic benefit, then we can't invest there. That is simple things. Then from this exploration also, that same thing will be applied. If we'll explore the ore minerals in large area, then we'll have to invest more. If from that area, if we'll get not that much ore deposits, that means will not any economic benefit. So that we'll have to decrease that area. So that for decreasing that area, we'll have to go for this different exploration stage. Then in regional recognition survey, that is mainly this main purpose of this exploration is the reduced to areas by identifying for further studies. First, we will have to select the areas in large area. That is what we are using here. 1:50,000 scale means 500 meter equal to 1 centimeter in scale. That is generally if we'll use that map, that 500 meter equal to 1 centimeter. Then another one is airborne or geophysical surveys. Here we can use this surveys through airborne. Through air also we can through airborne means with the help of without touching the ground. That is what if we'll go without touching the ground, that is called as airborne geophysical surveys. Through air we can this survey we can take that survey done by through air. Then this is what this is airborne magnetic, then airborne electromagnetic, then airborne radiometry. After airborne, then it will come to ground survey. In ground survey, generally if we go for ground survey, that we'll have to invest more and more. First, in recognition survey, we'll have to invest less and less. That is what with the help without touching the air means without touching the ground, we'll only survey from the air. That is what we'll have some less investment. Then regional geochemical sampling from this different 1 to 2 kilometers, just we'll get sample, we'll collect sample, then we'll do analysis and we'll see what are the different minerals present in that sample. Then regional geophysical survey, and whatever this geophysical survey will do in regional, not that detailed. That is what wide spaced. And also we can use here this photo geological and remote sensing data also we can use. Then next, if we'll go for preliminary prospecting, after recognition survey, if we go for preliminary prospecting, that here also just will reduce that areas. That is what our main aim of this exploration. Only we'll have to reduce that area. If that area is more in recognition survey, then in prospecting we'll reduce that areas. That is from few kilometers to tens of square kilometers. Then here in recognition survey we have used that scale map is 1:50,000, but here we can reduce the area, then 1:25,000, means 250 meter equal to 1 centimeter, or 1:12,500 scale, or 125 meter equal to 1 centimeter. Like that we'll have to reduce that areas. And here we can use this geochemical grids and the ground geophysical grids. We can use that different geochemical grids. Suppose we then will make grids in 500 into 500 meter square areas, and from that grid it will collect different samples. Then we will show that this is these samples are from this grid number 1, and also we'll mark another 500 and 500 square kilometer, 500 and 500 square meter, then grid 2. Like this we will have to first mark different grids are there. Then from that different grids we'll have to collect this different ore minerals from there. Then we'll have to analyze this geochemical sampling, different sampling we'll do, then we'll analyze at the lab. Then we'll get the different sample values according to we see this what is the percentage, what is the percentage of these ore minerals in that area. Then we'll throw this pitting and trenching. That is what the different sampling methods that in this preliminary exploration, in preliminary prospecting, we'll use this pitting and trenching to expose the ore body. Means whatever this ore body beneath this surface, that throw also trench also. If we'll, suppose one shear zone is there, and if we'll go for this collect the samples, that if one shear zone is there, so that trench will be done across the shear zone, not along the shear. If we'll go across the shear zone in every 20 meter, every 50 meter interval, then we'll get this many sample values. What are the different percentage of ore minerals? They are different in either in ppma or ppb levels. Then we'll know this, and from that trenching across the shear zone or across the fault, like that. Then if we'll go for preliminary exploration, that is what again that area will be that very small areas, that is, and here that also map scale also 1:2000 or 1:1000 scale. That means 20 meter equal to 1 centimeter, or 10 meter equal to 1 centimeter. That means what? First we will have to go from this 1:50,000 scale, then next stage 1:25,000, then now it will come to 1:2000. That is what will decrease the scale size. And if we'll see that is in large area, means from large area and will come to small areas. That is what. Then in this we can use this pitting, trenching, and bedrock sampling all out, means in all outcrop sections. Here what different sampling methods we are using, either through pitting and trenching, and that trenching and this bedrock sampling. There are different sampling procedure that based on this what type of that what type of what is the out of this ore deposits, that based on will use different sampling methods, either pitting, trenching, or bedrock sampling. Then next one is we can use this drilling method also. If you will do one drill, there will be invest of some lakhs and crore of rupees. And before go for drilling, then we'll have to see there is some ore deposits is there. Next is your what before going for, means before confirming for drilling, first we will have to see there should be some ore deposits are there. And if one shear zone will be there, either it is either it is your we'll have to see what is the deep of this shear zone. Yeah, what is the extension depth extension of the shear zone? Then accordingly we'll have to put this drill according to that 90° to this shear across, means then the drilling that will go up to either 60 to 120 meter depth or more than that. Generally, this is what preliminary exploration. We cannot we can put that much here. That means 60 to 120 meter depth, or it will go for 200 meter depth also. Then at 100 meter strike interval, here what if will go for drilling, that in case of gold will go minimum that strike interval is 100 meter. If one shear zone is there, then we will see measure the strike of the shear zone, and with the difference of 100 meter depth, then we can take one drill core. One drilling we can do. Then if that there will be base metals, then 200 meter strike interval. If there is limestone or any other deposit that is less economic, that will go for 400 meter or 500 meter depth. In gold, what that is generally controlled by this structurally controlled, or either fault or fracture. That is what will put some 100 meter. That what and also in the economic, if you will see this economic value, that gold has more economic value. That is what if we'll invest more and also we'll get more also. That is what our exploration tells. In then we'll go for detailed and petrological mineral studies, and in preliminary exploration we'll go for detailed petrological studies. That is what that is what here main important of geology. Geologists what then means they play most important role in exploration. That is what whatever the sample collected from the field, then that will carry the samples from field to your laboratory. Then from laboratory we can do some petrological and mineral studies. Then within this this mineral deposit, we'll have to see what is the strike length, then what is the width, and what is the depth. From drilling data, we'll get everything. What is the width of this outcrop, or what is the depth of this outcrop? Then accordingly, we'll calculate also tonnage of the ore. Then from this, ore reserves will get estimated. Then if we'll go for next stage, this is what detailed exploration. This is mainly based on your drilled at closer intervals. Then this is also different also mineral. This is what in detailed exploration already we have already confirmed this presence of ore deposit and there is economic value. Then this is the last stage where we will get this detailed exploration. In this, we will have to accurately determine the shape, size, and deposition of ore and grade of the ore body. Before going for this mining activity, this detailed exploration will carry out. Then from this detailed exploration, we will have to confirm the shape, what is the shape of this ore body, size of this ore body, and deposition and grade of the ore body. That is what we will get from this drill core data. And here we will also go for this EPMI analysis, that we'll know this what are the different mineral phases. Then processing of different also geostatistical methods we can use for this ore reserve estimations. Then this is what all these are detailed exploration. Generally in exploration we are using all these 4 different methods. Then if we go for detection based exploration, first in detection based exploration, first we'll go for aerial photos and satellite imagery. That is what in recognition survey will do some aerial photo and satellite imagery to see different alteration based wavelength. Here if we'll see this aerial photos and this satellite imagery, then we'll see what are the different alterations of minerals, what are the different. Based on that wavelength, we'll know either it is potassic alteration or arsenic alteration, or propylitic alteration, or alunites. These are the different clay minerals. That is what altered minerals. Through aerial photography and the satellite images, we can identify all this. Then after we'll go for airborne magnetic. Airborne magnetic means without touching the ground. We'll go through air. whatever this techniques will go without touching the ground. This is what these things that is used in your recognition survey. Airborne magnetic, that is what we will have to see this presence of magnetic ore minerals or not. Generally in magnetic ore minerals, VMS deposit, या CDX deposit, या porphyry deposit, या iron ore, या platinum group of elements and nickel chromite. If there is presence of any ore minerals, then we'll know this through airborne magnetic presence of this ore minerals in that particular area. That is what we are using this airborne magnetics. Then after airborne magnetic, we'll go for this airborne radiometric survey. In radiometric survey, that is what either if we suppose there is porphyry deposit, if there is some potassium alteration or any radioactive minerals present in that, then we will get the data through this airborne radiometric survey. Then next is your regional gravity survey. Then here in regional gravity, this is not detailed. This is a regional gravity survey. In the regional gravity survey, we'll differentiate either it is a heavy or low density ore bearing minerals. Either means VMS deposits or any sulfide minerals. Sulfide minerals are there. Suppose in ore minerals, you will see that is low density bearing minerals and high density bearing minerals. From this regional gravity survey, we can clearly differentiate this either it is heavy density or low density. That is what we'll go for regional gravity. Then after regional gravity, we'll go for airborne electromagnetic survey. In airborne electromagnetic survey, there is mainly we'll see this is based on conductivity of the ore minerals. Generally, airborne electromagnetic methods used for the different sulfide minerals. The sulfide minerals are the mainly this they are showing this conductivity of the ore. That's why we are using this airborne electromagnetic survey mainly to differentiate the sulfide minerals. That is what general sulfide minerals have the good conductor. That's why you are using this electromagnetic methods to identify different sulfide VMS or CDX deposit. Then we'll go for geological mapping. Then now this geologist they will go to field and they will see what are the different lithologies in the field and what are the different structures. They'll get a deep strike and depth extension of this means from that field they will get this deep and strike of this either shear zone or any lithologies, any rock types. Then seismic studies. Then seismic studies, if you see this seismic, will go for whatever these structures present for deep-seated structures and stratigraphy that will come. As the time is 10 minutes more, I think so we'll have to complete. Then after seismic, we'll go for ground magnetic survey to see these different magnetic ore minerals such as either VMS or CDX or porphyry. And then we'll go for detailed gravity. That is what that is same thing in the regional gravity, detailed gravity. First in that preliminary exploration, if we'll use this regional gravity, in detailed exploration, detailed gravity. That is what this exploration. If we'll go for some different stages of exploration, that is from recognitions to detailed exploration, we are using these techniques in different stages. Then we'll go for this ground magnetics. Then we'll go for detailed gravity survey to see also this different density of ore minerals. Then we'll go for induced polarization survey if that is ore minerals is disseminated deposits. Then we'll go for this induced polarization methods. Then we'll go for cell potential methods. If that is massive sulfides, then we'll identify this is through cell potential methods. Do trenching, then drilling, then like that. This is what these are the different detection based approach. But in concept based, what we'll see what is the source and type of ore fluid. That is what already this. So what are the different source and type of ore fluid? Already I have told that what are the different type of ore fluid you have source, that is either low temperature or high temperature fluid. That is based on isotopic or fluid chemistry or paragenesis. We can identify this either this source is low temperature fluid or high temperature fluid. Then after source, after if we'll confirm the source and type of fluid, then we'll go for fluid migration and pathways. Means if that fluid will be low temperature or high temperature, how this fluid will come out from below the depth to upper part of this surface. That is what we'll have to see. This is through fluid migration or pathways. That is what we will analyze this regional structure, or we'll see this tectonic evolution or structural analysis. From that, we'll see this fluid migration or pathways. And then trap or deposition. How this, if that fluid will get migrated, then how it will get deposited on the surface. That is what we will see. Then that is called as trap or deposition. That is mainly either when the deposition takes place, either lithology plays an important role, or also local structural analysis. You will see these local structures, not regional. In regional structures, we will see this fluid migration and patterns. But if we analyze some local structures, then we'll get what are the different conditions of trap or deposition of different ore-bearing minerals. This is what concept-based exploration. If we specifically focus on this concept-based approach, then I think exploration will be more holistic approach. And in a present scenario in India, what we are mainly focusing on this detection-based approach without giving importance on this concept-based approach. Only this academic people use in a great way, but if you see, there is different suggestions of source and gold bearing fluid worldwide. If you see this gold deposits in orogenic gold deposits, some people are telling this is mantle derived, and some people are telling this is magmatic derived, some people are telling this is metamorphic derived. Same orogenic gold deposits, but different people are different views. If we'll get the data, suppose if we'll collect the data and if we'll analyze this one, and if we'll directly plot and if we'll tell something that is derived from this, then that will tell different sources. And if we'll collect the data, then analyze, if we'll do some mathematical calculations, if that is source is suppose we will tell the source is magmatic, then how the secondary fluid after the, suppose this age is 2.5 billion years. Suppose this orogenic gold deposit general that will form at 2.5 billion years, and after 2.5 billion years there are many secondary fluid that will come out, and that will alter all these minerals. And if we'll see this fluid rock interaction process, then we'll get, if the source is one, suppose magmatic, then after the secondary or mantle derived, then the source is, if there is any secondary fluid that will come out, then that will alter the value. If we'll show some mathematical model for this alteration values, then we'll go for this single model. Not we'll tell this, some people are telling this magmatic or metamorphic mantle. Like that, some people are telling this major will be magmatic and minor will be this metamorphic. But there we'll have to sure what is the single source. Then we'll after the data we'll do some mathematical modeling. If this is the initial values, and if you'll see, if this is the initial values and these are the different low temperature and high temperature fluids, this is what this data will get altered through this low temperature bearing fluid. Then next model also we'll see, which after getting the data we'll go for your mathematical modeling. That is what then only we'll see this is the source is one origin. Then also if we'll plot this isotopic data, then if we'll do some fluid calculations, then we'll get all this isotope data within the C and D value. That is what that will show your magmatic or mantle origin. Then if we'll this is what source of ore-bearing fluid. Then second stage is your fluid migration, that is called as fluid pathways. Then how will know this fluid migration? First we will see what are the different rocks what are the different sediments that will get deposited during Archean time, then up to recent times. If we'll see, suppose if these sediments will get deposited, and this is just like a flattened surface, and according to time then it will get some extensional force will take place. If that during some extension if this is the basement rock, suppose tonalite, transimite, TTG basement rocks, then after then if some due to some extensional forces, if that some block will go below, that is what extension along basement fault. If that one any fault is originated during earth part, then that will go away from each other. Then that block will go to the depth, and when that block will go depth, then there is extrusion of mafic and ultramafic gas along this fault. That mafic and ultramafic fluid will come out. Then after mafic and ultramafic, then mafic and intermediate rocks will come. They are along that fault only. Then after this mafic and intermediate, then early granitic rocks will come out. Then after granitics, then felsic volcanic rocks will come out. Then we see one fault, how this if that is basement rock, and after this then ultramafic, then mafic, then intermediate, then granitic rocks. Like this, in one basin, so you will get several phases of different volcanic activity. Then finally, if you'll see, this is then if that domes, yeah, this domes will form. Then due to this weathering and erosion, these domes will get deposited below the basins. And if these domes, these sediments will get deposited in the basins. And in basins also, due to this heavy sediments, due to this load of these sediments, then this basin will get collapsed. If that basin will get collapsed, then that displacing the mid crustal melt. Then in the mid of this crustal melt, mid part of this basin, that will get slowly melt away. And if due to this horst and graben structure also will also formed due to this, as this will go below, then there is different horst and graben structure will form. Then if there will crustal shortening, then there will be development of some fractures also. Like this, if we'll analysis this, then different crustal scale shear zones will get. And first we'll see this basement rock. From this basement rock, if that is different fluid, different volcanic activity take place, then weathering erosions, then after weathering erosions, if sediments will get deposited in the basins due to loading, then they will go down. Then after then, if that swelling, after then if that swelling happens, then finally then crustal shortening will take place. After crustal shortening, then this due to the crustal scale or crustal scale fault or shear zones have been formed. And finally we'll get this is what called greenstone shear zone gold deposits. If you'll see for seismic survey, and we'll get this one type of structures. This is what we call, this is the analysis of fluid migration. This is how the different fluid will get migrated from below the surface to the upper the surface. And if we'll see for fluid migration, that will take this different cratons. Suppose in regional scale, if you see in different cratons, there is Aravalli craton, Bundelkhand craton, then Bastar, Singhbhum craton, Dharar craton. First, we'll analyze what are the different structures present in different cratons. Then we'll go for this. Suppose if we'll consider in Dharar craton, then again what are the different structures present in Dharar cratons, like that. And if you'll see these different gold deposits, that you'll see that different structures only will get the different gold deposits. And if you'll see, if you compare this Ilgran craton Australia, and this is the Abitibi greenstone belt Canada, then both all these orogenic gold deposits, that is only this along the structures only you will get all these gold deposits. Then next is your fluid migration. That what I have taken in Dharar craton, I have taken this some different orientations of the shear zones. From that, I have compared with this Australia. What are the different gold deposits in Ilgran craton Australia? Then we will compare what are the different orientations of the shear zone. Then in region, that's from that we'll get this different fluid migration. So that we go for this fluid migration, which how this fluid migration will take place from this regional structure. And if we'll calculate this fractal dimensions from this orientation of the shear zone, and we'll compare this gold deposits of India with your Ilgran craton Australia calculated in Australia, then we'll get like this. Along this fractal gradient only all this gold deposit after this orientation of the shear zone, then I have calculated some fractal values. Then after this fractal values, if we will compare, if I'll compare with this Indian gold deposit with Australian gold deposits, then we'll get this, all these gold deposits have been formed along this fractal along this steep fractal gradient. That is what fractal gradient plays an important role in formation of this in fluid migration activities. Then next, if you'll see that this azimuth, this azimuth of this shear zone, if you compare with this, I think now time is running away. Just within 2 minutes, I'll complete all these things. Then if we compare this Cartoon Australia with this Indian gold deposits, then we will see this is the at the this largest gold deposit that will occur at the Hati and Kolar, like that significant changes in orientation of shear mineralization of shear zone. Wherever the significant changes take place, then there is only such a world-class gold deposits happen. Wherever there is not significant orientation of shear zone, then we cannot get any large gold deposits. Then if we'll analysis this along this, this is what depositional point of view. If we'll see third stage or deposition, that is what we will do some either analysis of local structures or lithology. And this data will taken from bore drill core data. That is what from lithology, if we'll see analysis in detail, that is what we'll take the help of drill core data. From that, we'll calculate this, what is the fractal gradient. Here, what we have seen compared with this fractal gradient with gold. Then gold will get deposited along this fractal gradient, steep fractal, not this either low gradient or high gradient. That is only this gold is deposited along the steep fractal gradient. That is what fractal gradient plays an important role in the formation of deposition of gold deposits. And then I will calculate this host values, that if that is 0.5 to 1, that is also a good indication that shear zone will get this gold deposit will extend all along this drill course. That is what 0.5 to 0.5 to 1, if that host coefficient values within that will be a good significance to your exploration activity, and that is economic beneficial to. And here, if this is your drill core, if this is the drill core, this is the drilling point of view. If this is the just in case of Mysore gold deposits, this has been already published, and this is the model what we have given with along with Professor P.N.S. Rai sir. This is in this model what we have collected this different drill cores. This is the orientation of this drill cores, and if we'll from this drill cores, we have got this gold values, and from this gold values we will get this fractal values. Then we'll analyze like this. From this fractal values, it will see if this this gold will come along this. If this is the shear zone, this red color is your shear zone. This ore minerals have been found along the shear zone, and this is the orientation of this drill course. That is what perpendicular to this shear zone. And if you'll see this, if this fluid will come out through this shear zone, and if you'll analysis does what are the different gold value present in that, if you'll see and calculate this fractal values, we'll see we have seen what only this gold deposits have been deposited at steep fractal gradient, not the high fractal or low fractal. That is what importance of fractal gradient that plays an important role for the deposition of this gold deposits. And if this is the below the surface, if we go below the surface, we can take the help of this model. If we'll suppose if we'll go along the surface, along the shear zone, this is the model what this will help if we'll go along the surface, along the shear zone on the surface. And this will also tell same thing. If you go along the shear surface, if you take the azimuth of that shear zone, then from that if you calculate this fractal values. This is the case of Jonagiri gold deposits. If you'll see if this is the orientation of the shear zone, and we'll calculate this fractal values, and we'll know wherever this, and here we have shown, and there is one old working is there, and exactly we have seen wherever this fractal gradient, then we have got this gold deposits are there. What have already carried out by these British people, they have already taken away. And this is a simple methods. This is a simple methods where we'll get some area, in few areas, we will get this more amount of gold is there. That is what this fractal gradient plays an important role. And if we'll go along the shear zone, and also along the shear zone, will tell where you will get more amount of gold deposit there. Again, that will reduce our areas. If that will reduce our areas, then obviously that will the exploration cost is less. If our exploration cost is less, and so means within some investment, will selling more and more. That is what this is more and more economic benefit. This is what exploration. And if we academic people will do like that, this is totally new things. If we'll think in such a way that if we'll give some new techniques and new ideas how to explore all these minerals within limited resource. If we have more resources, then it's okay. If we have less resources, we can use this. In this, we don't have any cost or any, so that all these things. Okay, it's thanks for your patience, and I have told many things. I think it's already time. I have taken 5 to 6 minutes from my next speakers. Then sorry for that. And I think it's very interesting. And here what I have given importance to how this concept-based exploration that plays an important role rather than detection-based. In detection-based, there is nothing that to do whatever this instrumental data that will come and that will plot like this. Then that will give your data and I will tell this thing, these things. But that is not the case. We'll have to somehow we'll have to some brain exercise. You feel fluid rock interaction, that is what only academic people will do. And specifically this PhD research scholar, if they will come out and they will this type of research, I think that will get the exploration industry will get benefited from this. And thank you for everyone. Thank you all. I think I learned. If there is any questions from anyone, they can ask. If there is any questions from anyone, I think they can ask me directly. There is no problem. And otherwise, we will go for next speaker. Yeah, the Devasis, Dr. Devasis D. Mohanty, are you there?
Yeah, Sagar, good morning.
Devasis D. Yeah. Just our anchoring will announce to them.
Thank you, sir. I would now like to invite Dr. Devashish D. Mohanty. He is a scientist C at CSIR NIST, Jorhat, Assam. He is going to take the session on the topic Earthquake, Science and Study. Sir, I request you to please start the session.
Yeah, your sound is not audible now. You can Dr. Devasis. Yeah, Dr. Devasis, you can proceed. It's okay now that your screen is visible.
Yeah, Sagar, can you hear me?
Hello, your sound is not coming. Yeah. Now I'm hearing. Yeah. Now,
it's audible?
Now it's audible.
Okay.
Yeah, it's audible.
Am I visible now also?
Yes.
Yes, okay. Good morning, one and all. And welcome you again to this keynote talk of International Workshop on Innovative Approach and Recent Advances in Geology. Again, thankful to the convener, Dr. Sagar Swain, and the organizers for this wonderful workshop. So today I will be talking about the general topic, that is the earthquake, and what are the implications of the science and the society. And I'm not going through towards the research of any of the kinds. It's a general topic I have chosen for the students of the UG as well as the PG levels and the professionals who are the laymen and don't know the earthquakes. I have modulated this particular topic in such a way that it will give a glimpse of the idea to know what is the science of the earthquake and how we can be aware of these things, these devastations, so that we can help in the society in such a way that to overcome the earthquake effects. So let's first see what is the term called earthquake. So earthquake is nothing but the sudden release of the energies, and those things which are really responsible for getting the earthquakes are the faults. And what is the faults? Faults are the undulations. I don't know if the video is the animation is clear there. If you can see the animations there.
Yes,
hello. Sir. Okay, great. So the faults is nothing but the undulations on the surface of the earth or the lithosphere. You can see the one part of the rock gets down or up, and at the same time, when the deformation of this particular rock or the hard surface happens, the same time there is a chunk of the energy that releases in very significantly. That is called the earthquakes. And here you can see the cartoon I have shown here, and the focus and the epicenters I will be talking about in the next slides. What is the focus and epicenters? And these are the things which are really responsible for the earthquakes. We know the normal faults, and as well as the reverse fault, as well as the strike slip faults. I will be talking about them in more details in the coming slides. These are the three things which are really being responsible to qualify the earthquakes on the earth surfaces. So the thing which layman should know, that what is the focus as well as what is the epicenter. The point inside the earth at a particular depth where the slip happens, that is called as the focus. And if you make a perpendicular line and it touches the surface of the earth, that particular point is called as the epicenter. You may be knowing that in the new channels always it is being told that the earthquake epicenter is 15 kilometers away or 50 kilometers away or 65 kilometers away from this particular city. Let it be Bhubaneswar or let it be Delhi. So the thing is that people are not so much aware about the focus, because it is really difficult to calculate the focus. The seismologists always go through the focus, but the general people will know what is the epicenter, means what is the distance of the center of the earthquake from the particular station, that is called the epicenter on the surface of the earth. And what are the different forces and what are the different causes which is really responsible for the earthquakes? These are the tectonic forces. The tectonic forces which is being coming in the earth surface or the lithosphere, that is really responsible for about 90% of the earthquakes which is happening in the earth surface. And the earthquakes related to volcanism is count to about 8%. And whereas the induced earthquakes, that is the man-made earthquakes, that I will be talking in the next slides, that are responsible for about 3 to 5% of the earthquakes. And what are the biggest theory which is responsible for the earthquake phenomena is the elastic rebound theory. One of the major theories is the elastic rebound theory. We all know what is the elastic rebound theory. So I have already told about the earthquake, the focus, as well as the epicenter. Now the theory of earthquake tells that the elastic rebound theory, which has been proposed by Reid 1910, it says that the rocks, which are the rigid masses, which deform under the progressive strain until its strength is exceeded. Up to a particular strain, you can see here figures. If you can go for my pointer here, you can see that the figures tells that the rocks deform under a progressive strain. And when a particular strain and the threshold limit happens, then suddenly there is a deformation happens, and that particular deformation, the suddenly chunk of the energy is being released. That is called the earthquakes, and that energy is nothing but the heat energy, which you tell as the seismic pulses or the seismic energy. Okay, here the focus as well as the epicenters has been there. You can see the slip is here and the focus is at a particular depth, and if you can go for a perpendicular section and it will cut at the surface, which is called as the epicenter. So I have already told that the tectonic forces are the major forces which is responsible for 90% of the earthquakes on the Earth surface. So what are the tectonic forces? We know that the mantle, there is a huge mass of the magma, or the huge mass of the mantle convection shell is being going on inside the Earth. This shell moves in such a cyclic manner that it carries the tectonic plates. We have the major tectonic plates, are the 8 plates are there, and many of the minor plates are there. These magmas, which is always being moving in a cyclic manner, this carries the tectonic plates in such a way that it rotates in addition to this cyclic effect of this magma. That is called as the mantle convection shell. And when the plates are moving, it can move with respect to each other. It can make a jerk with each other, that is called the collision or the convergence, or it can go away from each other, that is called the divergence, or it can move sideways, that is called the transform boundary. I will be talking about in the next slides. So this thing is that the divergent is one of the cases also. When the mantle cycle is moving the 2 plates away, then the at that particular place from the crack there, the huge molten magma comes out. That is also responsible for creating of the earthquakes. And the greater example is the mid-Atlantic ridge. And the second one is the mantle convection and the plate tectonics, which is carried out at the convergent boundaries, plate boundaries. And you may be knowing that the convergent is at one rigid and dense plate is always being going down towards a less rigid plate. So the thing is that when the plate comes and it makes a jerk with another plate, that is called the convergence. And that convergence and the particular jerk, the forces that has been applied by the pushing plate, that makes the certain amount of heat energy to be liberated at that particular places. At the same time, it also makes the uplift of the topography. The same thing you can see here on the right hand side. Example I have given, that is the Himalayan mountain belts, that is the India, but our Indian plate is pushing to the Eurasian plate, and at the same time it makes the topographical effects, that is the Tibetan plateau is formed, as well as this convergent boundary is responsible for many of the huge earthquakes in this particular region, that is the Himalayan mountain belts. And the same, and the another term that is called the transform fault boundaries, it is also responsible for creation of the earthquakes when there are the no jerking or the no convergent as well as no divergent, but 2 of the plates will move with respect to each other. That is the sliding, that is called the sliding. And the example you can see the Alpine fault, that is in New Zealand. And this type of boundaries, the tectonic boundaries, are also responsible for creation of the earthquakes. So in a nutshell, I can say that the 3 types of the things that tectonics, that is, one is convergent, divergent, as well as the transfer boundaries, are responsible for creation of about 90% of the earthquakes on our Earth surface. So the next thing, I have already told that 8% of the earthquakes are due to the volcanic eruptions. And here you can see in the left hand part the characterizations of all the volcanoes here throughout our world. So when the volcanic eruptions happens, our plates are moving in a particular directions, and when it sees any cracks or fissures, the lava that is coming from a deeper part of the earth with a huge pressure as well as the temperature, when it gives when it tries to find any cracks, then suddenly there is upliftment of the lava to the surface, and this bunch of the forces will create earthquakes also. And Hawaii hotspot chain is one of the greater example of these types of hotspot volcanoes. And 3 to 5% of the earthquakes will responsible due to us, means the human activities, the induced seismicity. What are the induced seismicity? You know that the extraction of the oil and the dam effects, and the injection of carbon dioxide sequestrations, and injection of different liquids throughout the different surface of the earth to find out more productivity. These are the things that human behavior that presently that are being going on. Those are responsible for creations of the induced seismicity, which is responsible for about 3 to 5% of the earthquakes on our Earth surface. What are those things? The hydrocarbon storage and extractions, shale gas exploitation, geothermal energy exploitation, mining operations, carbon dioxide sequestrations, and dams. And these, when there is a huge amount of the process energy of the water or hydrocarbons have been there, and it may be deposited or it may be extracted, then certainly there is the chances of imbalance in the pressure, imbalance in the porosity, imbalance in the permeability, imbalance in the environment of the rock that has been present there. So this type of physical imbalance will definitely create the a certain amount of the energy, that is the heat energy, to be liberated. That is also called as the earthquake energy, that is seismic energy. So we know that what are the different mechanisms which really affect the earthquakes to happen on the earth surface. Then when the earthquake happens, actually what comes out, what is there? We seismologists are always reliable, and we seismologists are always thinking about the seismic waves which is being coming from the earthquakes. What are the different waves? That is the body waves as well as the surface waves. You can see here that there are 4 of the diagrams, 4 of the animations that I have shown here in this figure. If these animations are visible to you all.
Yes, sir.
Okay, yeah. So these are the P waves, S waves. The P wave is the longitudinal wave, and the S wave is in 2 particular directions waves. And relay wave is the retrograde motion. That particular motion is the retrograde in sense you can see from these animations. And the log wave is just like the S wave. And the thing is that these waves have been liberated when there is a huge earthquake, or the strike of the seismic source from the deeper part of the earth comes out. So these are the different characteristics of the rays which have been coming from different directions through the different surface of the earth, you can see. And if you go for the whole earth shape, then you can see the different waves, how they are traveling. And I am not talking about details because we have very short of the time. These are the specialized things, and these are the different waves which comes out when the earthquake happens. And what are the phenomena, what are the physics which governs these waves? And we know this reflection, refraction, diffraction, and scattering, and the different phenomena which govern this particular propagation of the waves throughout the earth surface. Reflection is a phenomena, the physical phenomena, where the rays which are coming from the source is being reflected away. The whole of the energy is being reflected away from a polished surface. Here you can see the layer B, and it is being recorded as a seismographic spectrum. And refraction is when there is a deviation in the energy, when deviation in the lithological velocities, then part of its energy goes to different layer. So that case we can say that it is a diffraction phenomena. And diffraction is when there is a pointed surface, then the energy which is coming straight, it goes in from that corner, and it goes to be recorded as the receiver functions. And scattering, we all know our sky is the greater example of the scattering effect. It is a zigzag motion, and it makes the particle, when it finds the particles, it gets in different directions that goes. So these 4 phenomena, physical phenomena, are really answerable for the propagation of the wave throughout the earth surface. So for your kind information, these are the different waves I have already told, but here more emphasizedly and more characteristically, I am telling that these are the different crustal phases I have shown here. Crustal phases and the mantle phases, which is if you want to know about the mantle, the seismologist use the mantle phases to know the convection things which is going on in the mantle, and to know what is really happening in the mantle cycles. So you have to know, then you have to use these mantle phases, PS, like this. And if you want to know the crustal dynamics, what is really happening in the crust, then we have to use these crustal phases. And so far, if you are so much concentrated about the core phases, that is what is really happening in the core, and what are the different things which being responsible for the core, then you have to use the different phases, that is the core diffracted phases, because at the very deep we cannot go for the reflection. Then these phases are really responsible for the refraction effects. So these are called the core phases. So these are the 3 fundamental phases, that is the waveforms that we really use, the seismologists really use to find out the different dynamics. What are the crustal dynamics to be known with the crustal phases, the mantle dynamics to be known with the mantle phases, as well as the core phases are responsible for the core dynamics. So far we know that these are the different waves, and these are the different things, these are different energies and phases that are coming from the earth. So how you can measure them? Actually, what is the thing that how you can measure these phases? That is also a real challenge. So we know that the things is called as the seismometers. seismometers, the mechanism is really nothing but the physical phenomena which is governing the mechanism of the seismometers is the Faraday's law. So far, you can see the two figures that I have shown here in the upper part. These are the two very traditional seismometers that were used in the very past, means the vertical seismograph and horizontal seismograph. Why these two things are there? Because when our earth shakes, it is not that the earth will only shake in the vertical direction, it may shake in the horizontal direction, is not it? So there are the three components. Basically, the two components we feel, that is, one is the horizontal component and another one is the vertical component. So to find out the horizontal motion of the earth, previously we used the horizontal seismograph, and when we have to find the vertical component of the earth, then we have to use the vertical seismograph. These are the two traditional seismographs that we call the analog seismographs that have been used. But present day these things have not been used. We are using the broadband seismometer. Broadband seismometer is the new seismometers that have been presently being used to sense these seismic signals. And what is the long period and seismometer, and what is the short period seismometer? When the earthquake gives a smaller frequency, then we have to use the long period seismometers, and when the earthquake gives a longer frequency, then we have to use the short period seismometers. And to overcome these things, we don't need these two type of the seismometers. This we have to replace it by the broadband seismometer, that it covers whole of the range of the long as well as the short period, and it also takes the medium range also. So the seismometers is nothing but the digital sense of the horizontal as well as the vertical motions of the earthquakes, and it is to be represented in our digital signals, that is the after amplifications. So these are the instruments that we have used. But how to know what is the earthquake effects? There is certain scale we have to know that what is the effect of the earthquake, is not it? So here the left hand side, the figure is a destructive earthquake that has happened in the Haiti. And this earthquake particular happened in 2010 January 12, and it is a magnitude of the 7, and you can see what is the magnitude of its destruction in that particular day. If you can imagine, around 200,000 persons died, 0.2 million persons died in that particular earthquakes, and that huge loss of the economy of that particular regions. And if you can say, how can we measure the earthquakes? That the two definite things are there, means two definite scales are there, that is called the magnitude scales as well as the intensity scales. I will definitely tell what is the difference in between the magnitude as well as the intensity scale. The magnitude scale is always being ranging from, that's for the Richter scale proposed by Richter, is ranging from -1 to 9, or you can say in a simple way from 1 to 10. It always determines the intensity, or it always determines the magnitude of the amplification factor. Means what is that? Is the amplitude when the wave is coming. That is nothing but it is the time series. You can see here this time series, nothing but the different amplitudes it gives with respect to the time, and 10 to the power 4 microns is sorry, 1 centimeter. So here you can see the magnitude is been given at the x-axis, horizontal axis, and in the y-axis you have the microns, that is nothing but the amplitudes. So here if you can range from -1 to 1.5, the earthquakes which really happen on the earth surface is being not felt. Every time it happens, the microquakes, and even if the huge loaded of the trucks as well as the lots of trucks in the one go they goes, then it can create the earthquakes up to a level of 1 or 0.5. But it cannot be felt to the human beings because we are not so much accurately devoting our energy, or we are not so much accurately devoting our knowledge to see if what is happening. But when the things are beyond that, that is 1.5 to 4 or 3, then it is called the minor earthquakes. Yes, we the human beings are able to find what are the minor earthquakes. We can really realize the minor earthquakes. And then 4 to 5 is small, and 5 to 6 is moderate, and 6 to 7 is strong earthquakes. That is being we are going towards the destructive sides, and 7 to 8 is major earthquakes, and 8 to then above up to 10 is called the great earthquakes. And you may be knowing the 2004 tsunami is a great and a devastating earthquakes, as well as from the 7 earthquakes I have already shown here, the Haiti earthquakes. What has happened here in the Haiti is a strong earthquake. Okay. So this I told about the magnitude scale. Magnitude scale is always being dependent upon the amount of energy that is being released by the earthquake, that is measured in the Richter scale, and the magnitude scale ranges from 1 to 10. It depends upon the amplitudes that I have already told. But how can know that this particular amount of magnitude is being so much destructive or not? May I tell you one example, that if an earthquake which is being happening at a depth of 100 kilometer, suppose it is a magnitude 7 earthquakes, and if you are residing on a rock mass, that is a stable rock mass, hard mass, then the earthquake is not going to do so much destructions. But if you are now residing on a liquefied zones or some of the heterogeneous, more heterogeneous zone, and the earthquake of magnitude 4 or 5 is there, and it is happening at a depth of 40 kilometer. I told that 7 is happening at a depth of 100 kilometer and it is not making any difference. But if you are sitting on a particular zone of liquefied zone, and the earthquake is happening at a depth of 40 kilometer and it is 4 to 5, it can make a loss of destruction. So it doesn't mean that the earthquake of 7, even if it releases so much of energy, that is about 1,000 times more energy in compared to the earthquake 5, it cannot give you so much jerk, it cannot give you so much destruction towards a earthquake which is happening at a particular small shallow depth, that is 40 kilometer, and it is in a liquefied zone. So we should not have to go for the magnitude of the earthquakes, but we have to see what are the different lithological units where we are standing, or where we are sitting, or where we are been living. That is the most responsible factor to know what is the destruction of the earthquakes. In the same way, to know the destruction of the earthquakes, there is another scale which is called the intensity scale. How the scale really works? This scale is on the observation of the seismologist. This scale is on the observation of the geologist, who really goes to that particular region and sees what are the differences, what are the destructions has happened. On that particular basis, they make this scale. So here you can see the calibration of the magnitude as well as the intensity scale, how they really work to characterize a particular trend of the earthquake. So earthquake is not that it only happens on the land. It can happen on the inside the sea level. And when it happens in the sea level, that is called the tsunami. Su is harbor and nami is the wave. It is the Japanese wave. It is a Japanese name, and the things which the earthquakes when happens in the due to the undulations of the collapses of the rises of the plates tectonics in the inside the sea level, inside the sea, then it is called as the tsunami. And the tsunamis are the most destructive things. And initially the waves largely underwater, they very fast toward the shore. Means what is that? When there is the undulation of the masses, when there is the displacement of the water, the sudden displacement of the water due to the plate tectonics, and you know that what are the level of the water inside the deep oceans? It tends from 4 kilometer to 16 kilometer depth, and you can imagine a 16 kilometer depth of the water mass when it is gets undulated, what type of energy is being really coming out. And that particular energy when it comes, it travels with a very fast speed when it is in the deep of the ocean. But when it comes to at the shallow level, the energy goes on decreasing. So what I am actually trying to tell you, that when the huge velocity of the energies comes towards the shore, that the shore of the sea, then the velocity of the water body goes on decreasing. And to maintain the particular energy, that we know that our energy is always been in the conservation side, means the kinetic energy and potential energy should be equal every time. So when the kinetic energy is being minimized, that is the V is minimized, then velocity is being minimized when coming to the shore. To make the effect to be a constant of the energy, the depth or the height of the waves really goes to increase. The huge height of the energy of the water level goes on increasing, and suddenly there the destruction happens. So what is the real thing here? You can see, if you can see my pointer, you see the height 1 meter of the water level height with a speed of 700 kilometers from the deep of the earth ocean is being coming, and when it is crosses to the self margin, and when it goes to this push to the shore, and suddenly there the speed goes on decreasing from 700 kilometer per hour to the speed decreases to 40 kilometer per hour. So when the speed goes decreased in such a huge manner, then suddenly there is a increase in the height. Can you imagine a 10-meter of the height? If you can know that the coconut trees or the palm trees are the 10-meter of the heights, and this particular height of energy, this particular height of water level, which comes with a speed of 40 km/h, then what will be the destructions you can imagine? That really happens. And this is the example that I have shown here in the areas that has affected by the 2004 Indian Ocean tsunami, that is the Boxing Day tsunami. Here, see the global scenario of the tsunami effects the Asia. You can see in Asia, the most of the things which have been happening is in the Japan. The Honshu Plate as well as the Japanese Plate as the most destructive plates where inside the sea, inside the Pacific Ocean masses, which are responsible for creations of the tsunamis effect. And you can see also in Europe, Africa, North America, and South America, these are the things which have been really responsible for creations of the tsunami effects due to the destructive plates inside the sea masses, and the things have been more dense in the Japanese continent. The plate boundaries, the global scenario, and here one can the layman should know that I have already told that the tectonic forces have been responsible for about 90% of the earthquakes which is happening. And if you can take whole of the continent, whole of the world in your palm, then you can see the ring of the fire, that is the Pacific Ocean, that is the circum-Pacific belt. You can see that ring, that is nothing but the collision and the collision and the mass up of the different plates, minor, major plates. Lots of plates have been there, and that the tectonics is happening. Those are responsible for creation of such a huge, like a horse shoe shaped fire ring. That is called the ring of fire. And for your kind information, I will tell that the 81% of the biggest earthquakes on the earth for annually has been arriving from this ring of fire, and the 90% of the whole energy of the earthquakes has been concentrated in this whole ring of the fire, and the rest is from the rest of the world. Okay, and you can see how destructive and how far this ring of the fire is being so much dominating in our earthquake seismology. So from magnitude 5.5 to 9.5, the different types of the different magnitudes of the earthquakes you can see here, and these earthquakes are also comprised of the many of the volcanoes here. So far we have known that what are the signs of the earthquakes, how this phenomena of the mechanism of the earthquakes happens, how it really destroys and destructs the things, what actually it makes the phenomena on the surface of the earth, how is responsible for the tectonics, or the changes of the topography, as well as the changes of the geodynamics of the earth. So far we have to know what are our responses, what are the responses of these earthquakes to the social people, how the social people should behave on the case of the earthquakes like the destructive things. So this is the clear picture of the devastating earthquakes in India so far has happened. 1897, the Shillong earthquake, you can see the church. After the earthquake, the church is totally destroyed. 80.8.7 epicentral magnitude earthquake that has happened. And Bihar Nepal border earthquake, that is 1934 earthquake, that is the Tamku village in the Nepal, which has happened 8.1, and the Assam earthquake 1950. And the tsunami of the India I have already told, that is the one of the most destructive earthquake of 9.1. And the Nepal earthquake we all know in 2015, the Gorkha earthquake 7.8, that is 77 kilometers from the Kathmandu, how destructive it was. So far, if you go for the localized map of India, you can see the seismic zones, and these are the different zones of India, and those have been characterized by the seismologists. And the seismic zone of India is about 59% of the land area of India is liable to seismic hazard damage. So far, we can tell that for the layman, we can tell with our naked eye that the India, a country of one of the highest seismicity rates. Yes. So if you go, these are the zone 5. I have given here the zone 5, the map I have collected from the NCS. You can see the zone 5 is giving this magnitude, that is the intensity zone is 5, and where the lowest intensity is zone 2. And here we are sitting here, our lab is sitting here, CSR Nest, and we are sitting in the zone of the 5, that is one of the most seismic potential zones in the world. And if you talk about the Dhanbad, you persons have been sitting in this particular zone, that is the zone 3, the moderate zones. Then the moderate risk is the intensity of 7 of the earthquakes can happen there. That is the thing. So you should not be very much relaxed that there will be no earthquakes, but you should be also careful about the seismicity of that particular regions. So these are the seismicity which are happening in the northeast regions, that is the most active potential seismic zones in the world. And here is the topographical map of the northeast I have shown. So what will be the real response to the social people when the earthquake is really happening? How the people can deal with that particular situation? How the people can know what is really happening there? So we have to be very much careful before the earthquake hits and during the earthquakes, as well as the after the earthquake has happens. What are the things to be done? Now, there is the science I have already told, and there is a run up of the different seismicity. Like our lab is always recording the 24/7 seismicity. Then all the measure of the seismological labs are also recording the seismicity. We have to very much careful about those records, and we have to plan, we have to prepare, and we have to recover at the sites so that we can culminate with the effect of the earthquakes. And when the earthquakes really happens, we should not be panic. The social message to the people is that, to the students, to the people, to the laymen, is that never gets panic. Always been drop, cover yourself underneath a hard surface and hold on until the shake is being over. Don't be panic. And after the shaking stops, other different things are there. I'll be talking about them in my next slides. And the 6 pillars of the earthquake management are the earthquake resistance constructions. Nowadays, the constructions are happening with a very other manner. We should very much give concentrations. We have to very much give our knowledge to how the construction should be reinforced, seismic reinforced, and the regulation and enforcements. We have to always maintain the government regulations and enforcements, and the awareness and preparedness within the people and within the social people is being really responsible factor to overcome the big events. And capacity of development, we have to develop certain confidential. We have to also develop the confidence with our neighbors, with our social people, and the emergency response capability enhancement is one of the best things we can do to overcome these situations. So actually what we have to do before an earthquake. These are the things that I have written here, the left hand side panels, that there are things we have to follow for before an earthquakes. But please go through the red stripes, that they know the electric and the water shut off locations in your house, because those are very dangerous things at the time of the earthquakes. And heavy objects, glasses, cutlery, and should be kept in the lower cells. And the flower pots should not be kept on the parapet, because if you can make this type of the arrangements, then at the time of the earthquakes it may fall on any of the persons and it can make harm of you. So these are the things you have to really think of about an earthquake, because you have to always prepare for an earthquake, so that the zones it will be always be beneficial for the zones of the 4 and 5, from 3 to 5, to always be prepared for an earthquake. So these are the things I have already shown. And at the time of the earthquakes, definitely if you are indoors, take over under a desk, table, bed, or doorways, and against inside the walls and staircase. Stay away from the glass doors, because it can harm you, and the glass panes, windows, and outside the doors. Do not rush to go out of the building to avoid this stampede. Because I know that when this huge large shock happens, and the major shock happens, people get terrified. People have the havoc inside their minds, that what is really happening, what to be happening, and how we can manage ourselves. Please don't do that. The stampede will kill you when you go in a hurriedness, and when you go in a fashion that the huge amount of the persons have been going in a regular fashions, and your narrow slope down has been there, and you cannot overcome those things. So you cannot overcome the loss. At the same time, the causality should be higher. So don't be so much panic. Just hold down, cool down, and you protect yourself. If you have a chance and you are thinking that your building is being collapsing, then certainly get out of that building, and very smoothly, very finely you get out of the building, because the building should not collapse in a chunk of seconds. It can take time. It can take 1 or 2 minutes or 3 minutes of the time to totally collapse. So in that particular time, you can come out from your buildings if you are in the upper stairs. So don't be so much panic to come in a hurriedness. Okay. And when you are the best thing is that when you are driving, you please stop your drive. When you think that there's something is happening and my vehicle is being unduled, my vehicle is not going in a regular fashions, then please stop your vehicle. Don't go. And the major thing is that if you have the pets inside your home, then please make them free. They should go out of the field. They should go from out of your house so that they can rescue themselves. And don't put on your electricity as well as the fires. It can make lots of difficulties in that particular situation. So I do not use the candles, matches, or other open flames and put out all of the fires. So what are the things done on earthquakes? Do not spread rumors. That is the major thing you have to do. Don't spread the rumors actually. Because the thing, I know that some of the people they say that this type of destruction is happening, what should be done, this epidemic is coming out and this is happening. But please don't spread such type of the rumors. Be prepared for the aftershocks as this may strike. Once a biggest quake is there, then there is the chances that lots of aftershocks after that particular huge event, then the chances are there that the quakes will happen, the small quakes will happen. So be prepared with them. Don't think that after a major shock the things has been over and we are now safe. No, you have to just wait for some time, maybe half an hour, maybe in 1 hour, because the shocks will come and the small shocks will come. You also prepare for that. Close the valve of the kitchen gas stove if it is on it, and if closed, do not open. Don't use open flames. Do not operate the electric switches. It is and the gas leaks, because at the time of earthquake will come, then it will blow out the gases and the things will be very destructive in that particular case. Check the water pipes, electric lines, and the fittings of the damaged sort of the main valves. Do not touch wires or the electricity. And the major thing we have to do is that the old parents, as well as the old people, the old neighbors, which have been present, you have to just go and you have to just see if they are okay. If not, then please take them to the medicals. Please take them to the nearby hospitals, and please take care of your neighbors as well as your family members. That is the major thing you have to do. And certainly one more thing is that after the great shock is being there, you please put on your televisions or your radios or your any telecommunications where there the news is flashing, and what are the different instructions that government is giving, as well as what are the things is happening in your nearby areas that you should know from these television channels. So please put on those things, and don't be hurry and don't be panic in that particular case. So these are the things from myself. And more of the things I have to tell here, that when we persons are really thinking that earthquakes 1 minute please, when we are thinking that earthquakes are so much destructive and it will kill us, and in one go, earthquakes are also blessings for the seismologists. Without the earthquakes we cannot do research. One earthquake gives us lots of waves, and we gives us lots of information so that we can know what is really happening within the earth. We should know what is really happening, what is the mechanism which is governing the earth processes. So whenever the earthquake is being a destructive things, it may be treated as a very fundamental as well as a very constructive things for others. So if the general people, the layman, should know what to be do, what is your to-do list to do at a particular time of the earthquakes, then it will be of no affair of destructions. That's from my side. If any question from your side, please. Yes. Any question?
Hello.
Yes, yes, please.
Am I audible there? I'm talking from Nepal.
Hello.
Hello.
Yes, yes, please go on.
Thank you, sir, for your nice presentation. I have a query about the seismic data. I think Devashish sir is expert in the field, so I'm putting these questions. Sir, would you please tell me about how we can separate the aftershocks from the major shocks in earthquake phenomena? Though it is beyond this slide or presentation, I have a small query, sir.
Yeah, so your question is how to differentiate the aftershocks from the major shock.
Yes, sir. Yes. How can we differentiate them? Those things are aftershocks, or this is major shocks, something like that.
Yeah. Thing is that if you are certainly living in a particular area and for a long period of time you don't have any experience of any earthquakes there, and suddenly a strike the earthquake. There are two phenomena called the before shocks and major shock as well as the after shock. So the thing is that major shock or the major one that makes you feel that some destruction has happened. Okay, it is not that there is no some straightforward law is being there that you cannot tell a after shock as a major shock. Yes, you can tell the after shocks as a major shocks, but actually the people which are residing in a particular area, when they feel a fast or the relative the major shock, which is the really destructive one, they tell it as a major shock. And when the major shocks has happened, then at a particular time interval, you may have, if that particular region is not getting the earthquake for a long time, that is we call as a seismic gap, or it may be some particular regions where if the major shock is happening, then there is a chances of relatively small magnitudes of the earthquake. Suppose it happens the 8 of the earthquakes or the magnitude 7 of the earthquakes, then the chances of 6 or 4.5 like this type of earthquakes can continue. It may continue. I'm not telling that it should continue. It may continue with respect to time. So these are called as the aftershocks. And there is also a phenomenon called the before shocks, that prior to a major event, suppose 8 events will happen, then according to the geology of that particular area, then the shocks of the magnitudes of the 4 or 3 or the 4.5 will happen with certain gaps. Within a month or within a time frame, we can get certain shocks, so that you can think and you can talk about in your area that something biggest is going to happen. So these are called as the aftershocks as well as the main shocks. Am I clear to you?
Sir, I have one more query. Sir, can we set a certain area in a circle and we can say aftershocks are going to happen in those areas, or in a box, something from, let us consider Gorkha earthquake, and can you say that within a certain regions where aftershocks are happen in the future? Can you say something like that? Um,
Can you please repeat your question? Actually, your voice is a little not audible. Please go on. Please go on.
I want to know that let us suppose Gorkha earthquake that was happened in 2015, and
Yes.
can you set certain circle around the epicenter of the Gorkha earthquake, and we can say the regions bounded by the circle is region for aftershocks. Can you say something like that?
Yeah, you were particular asking about how to know these seismic potential zones. Suppose a
Yes,
Gorkha
yes, sir.
earthquake
Yes.
has happened, then how can you know that what is the most potential zone of the aftershocks will happen? Isn't that it?
Yes, sir. Yes, yes.
Aftershocks will happen in the particular area where the major quake has happened. It will happen in that nearby areas only. Okay, it is not that
Yes.
if earthquakes happened in the Nepal, in the Gorkha part of the regions, it will happen in the Hyderabad sections in the afterquakes. That is not the things. Okay, it will be the nearby areas. Suppose it is 500 kilometer or 600 kilometer the earthquakes which have happened after the major shocks, that is called the aftershocks. And the main thing is that how to know the seismic potential areas. Suppose leave about the major earthquakes, leave about the minor earthquakes, leave about the aftershocks. So how can I know if certain area is being now developing the energy that is going to build up the area, so that in the near future we will get the earthquake? That is called the seismic gap. You have to measure, you have to map where the energy is being liberating. Means suppose if you take the whole patch of the Nepal map, you can see the western Nepal as well as the central Nepal are been so much dangerous. And the eastern Nepal also many of the earthquakes are happens, but in compared to those things, it is little bit lower. So the things that we can predict that in the near future, it may be the earthquake is transition. This transition has been happening. Suppose I am giving you the another examples of the Assam gap. After the 1950, there is no such type of the earthquake has happened. So from that, is a huge gap. It's from the 1950 to today's. That is the huge gap, and we can say that from the neighbor regions of the Assam gap, lots of earthquakes are happening. We know that it is a collision zone and things are happening, but in the particular gap, the things are not happening for a huge while. So it is a potential reason that in the coming future, the things are going to be harsh to us in that particular area. So this is called the seismic gap. And similarly, a central gap is there in the Indian regions also, which is big for a whole, for a huge while there is no earthquake happening, and this is a potential region of the earthquake also. Okay.
Hello, sir. Sir,
Okay,
sorry for the
thank you
interruption.
very much, sir. Thank you. Thank you.
Sir, we have very less time, sir. Please conclude. We have to start poster presentation, sir.
Yeah. If anyone has any of the questions, please go on, and we are running by sort of the time. So Dr. Sagar will allow for the questions, then the people will then people will ask me. It depends upon Dr. Sagar.
Okay, audience can ask question from Devasis now.
Yes, anyone want to ask me quick questions, please?
Okay, those who have questions, I think they will email to you, Dr. Devasis.
Yes.
So. I
So
think
students,
whatever this question, I think they will send me in the.
yeah, my mail is flashed there. My mail is in my. You have the YouTube also. It will be flashed. The whole of the things will flash in the YouTube also. You can get my mail there, and be very free to contact me at any type of the research or any type of the questions you have regarding the earthquake seismology. Okay. So I think it's over from my side. I am really thankful to HOD Geology as well as the organizers, as all the dignitaries and all the students and persons who have been present here with their dedications of the time to know the science and to know about the earthquakes. Thank you very much. Thank you, Sagar. Thank you.
Yeah, thank you, Manti, Dr. Devasis. Thank you for your such a nice presentation. I think all the participants will benefit from this presentation. Thank you so much
Thank you.
for such a nice talk.
Thank you. Thank you.
Thank you very much, sir, for this interactive session. You blessed us with a lot of knowledge. And I'm handing over to Niharika to start the poster presentation. She's our host. So Niharika, please start.
A very good morning to one and all present over here. Myself, Niharika Pandey, and I welcome you all on behalf of the P.K. Roy Memorial College to this poster presentation session. Before I proceed, I would first like to introduce our esteemed judges of today's competition. So I first welcome Dr. Ranjit Nayak, Department of Earth Sciences, NIT Rourkela. I also welcome Professor P.N.S. Roy, Department of Geology and Geophysics, IIT Kharagpur. Next, I welcome Dr. Amalindu Sinha, former Director, CSIR, CIMFR Dhanbad. Next, we have with us Dr. Sagar Kumar Swain, Head of Department, Geology, P.K. Roy Memorial College, Dhanbad. We are blessed to have you all here. So now, without wasting much time, I would start poster presentation session with hope for the best. One more thing which I would like to convey to all the participants that the time limit for completing your presentation is 5 minutes. So please try to complete within the given time frame. So with that note, I would like to call our first participant, Mr. Aditya Verma, Department of Earth Science, IISER, Kolkata.
Thank you.
Aditya, start your presentation.
Yeah, I'm just showing it. Okay. Now is it fine or available?
Visual, you can proceed. Just you will make in presentation mode. Yeah, it's fine.
Okay. Good morning, all the chief jury guests and all other dignitaries and friends. Sir, the upper portion is available. because here I'm showing some settings. Hello.
Any question?
Yeah, my presentation is available now.
Okay, yeah, you can carry on.
Yeah, okay. So my today's topic of presentation is the geodynamic cratonic landmass of Indian subcontinent, the Archean benediction of the nature. So here I will try to describe how India is placed in terms of a cratons, because across the globe there are several countries where we won't find any such craton, but in India we have 5 cratons, which offers us a wide variety of exposure to understand the early Earth and their tectonic history and their evolutionary history. So if we start from the abstract, so this is the top the geological map of India, where we can see that all the 5 cratons are spread in the peninsular part of India, and if we try to see, it is mostly composed of a granitoid rock bodies. And granitoid rock bodies, as we know, it is generated by the partial melting of the diverse crustal and mantle sources and their subsequent differentiation of the primary magmas. And several geodynamic processes are also involved in this way in order to do that. So the cratons, all the cratons are covered or bordered by the mobile belts. The 3 mobile belts are here. The first, the southern portion is here, southern granulitic terrain. In the eastern region, this is the Eastern Ghat mobile belt, and in the north and in the central portion, this is the CIS, that is Central India Shear Zone, that is Central India Tectonic Zone, it is also known as. And if we try to see, all the blocks, all the cratonic blocks and the granitoid rock bodies are the significant archives to understand the early Earth and their lithospheric evolution. If we see the cratonic Indian cratons, so it has a huge potential to understand or to address the global issues of the Archean crustal evolution, and it can be also helpful for solving numerous global geological quests. If we come in a research gap and the scientific problems which motivates us for this kind of a study. So this is an overall study of all the cratons which is present in India. So we have the informations, but the information is in fragments. We don't have any collective measures or the collective informations which are correlated with each other or all the cratons and all other terrains in India as compared to the global scale. The locality specific informations, we have some informations in some particular cratons, but these are specific localities, means at some point we have plenty of data, but at the same time in other locations we don't have enough data. Whatever the data is available, that is not readily available for the international readers, so this is also another challenge. So if we see as I described, the granitoid rocks are the mostly dominantly composed of in the Archean cratons, and their formation and the genesis I already described here. So granitoid rocks are acting as a windows into the earlier the geodynamic processes and the secular changes. Many such rock bodies are linked with the very important significant economic mineralizations like the gold, copper, metals, and very metal and non-metal are metals and non-metal deposits are also associated in all the craton, whether it is in a Bundelkhand craton, Basar craton, Singham craton, and Dharwad craton, all are in the Singham, in greenstone belts, and other metallic deposit, whether it is a manganese ore or the copper ore or all other iron ore, rich iron ore deposits. So the objective of this kind of studies is the overall review of Indian craton and their evolution of the early Earth. And with the help of their such kind of studies, we can understand like how the globally what is the contribution of a we can understand that what is the what could be the contribution of Indian cratons as compared to the global cratons. So here some data are taken from the Day in Moyen 2020 and the Mer 2010. If we see here the Bastar Craton, this is the Bastar Craton, which is the average age is about 3.5 to 3.6 billion years, which is similar to the Bundelkhand Craton and the Singhbum Craton. If we come over the Western Dharwad Craton, that is the western portion of the Dharwad Craton, and this is the Eastern Dharwad Craton, which is separated by the close-fit granite. So the Western Dharwad Craton's age is about 3.4 to 3.5 billion years. That is, those are the average ages, and the available and the Aravali Craton is about 3.3 to 3.4 billion years. And the youngest Craton, that is the Eastern Dharwad Craton. If we see here, all the red rock bodies or the red terrains, they are showing the granitoid rock bodies. So with the help of this, we can assume how much the contribution of the granitoid, and all the saffron color points are the granitoid bodies. Several of terrain and the other rock bodies are still not defined or what is their exact age. So each craton has their unique evolutionary pattern that makes it more difficult, or that makes it more challenging to understand. So several successions of the relatively long period of episodic ETG magmatism occurred during at about 250 to 850 million years long period, and it followed by the granitoid diversification about very short period as compared to the earlier one, that is 30 to 100 million years, with signatures of the inputs from the both mantle and the crust, and a wide range of magma sources, melting conditions, and subsequent modifications can be observed with this with the cratons and the fractionation, assimilation, and other mixing etc. processes. So after knowing the geochemical studies, or after the analysis of the geochemical studies and isotopic study, when we come over when it occurred or when it happened, like a subduction occurred or succession happened or anything happened, so when it occurred, so for recognizing that, we used zircon crystals for their dating methods. If we compare about some of the basic features of the cratons, Indian craton, and their potential, so from the Bastar Craton here, this one is the Bastar Craton's map. It has found that a world's oldest potassium-rich granite occurred from the Bastar Craton from Rajesh et al. 2009, and it is about 3.6 the world's oldest magmatic zircon, because the oldest crystal zircon of the uh, Australia, that is a detrital zircon, but this zircon is from this zircon is oldest magmatic zircon, which is found in the older metamorphic tonalite gneiss, which is the raw host rock is a age of 3.4 billion years, but the zircon grain's age is about 4.24 billion years. The Bundelkhand Craton is the smallest triangular craton. This one is the Bundelkhand Craton here. This one. So it is a bit controversial, because many researchers think this is the part of a Aravali Craton, or many researchers think no, it is a separate craton. So it's a matter of further studies. And as compared to the Western Craton, Western Dharwad Craton and the Eastern Dharwad Craton, so Western Dharwad Craton is far older than Eastern Dharwad Craton. So if we come about the studies of the zircon, so why it is special? So it's we often call it as a time capsule, because it is the only proxy of the oldest rock on Earth, and it preserves robust rock record of chemical and isotopic characteristic. It is very resistant in nature. That's why we can found it from one of the oldest rock, and the history of and with the study of these crystals, we can know the history of the generation of their parent rocks as well. So as I described here, this one is the Concordia image of Concordia plot image of these zircon crystals, which is showing here about 4.24 billion years from the RM sample RM5, and this was 4.03 billion years from sample number RN1. This was from Chaudhary et al. 2018, as I described earlier. It occurred from the Champua region of the Sengham Craton, and these describe that the Sengham Craton is the oldest crustal part in India, and it originated from the reworking of the older crust prior to the 4.2 billion years. If we come up with the summary and conclusion, so the present and fascinating and a complex geological knowledge is the outcome of invaluable endeavor of the earliest geologists who have worked very intensely, even in unhostile terrains. And the granitoid rocks are important sources of metal, thermal fluids, and are genetically connected with a wide variety of metal deposits. We need to remap the critical areas which is requirement for the time or for the hour, requirement of an hour, and the geochemical and isotopic data are still inadequate for several granitoid rock bodies, specifically in the Bastar Craton, here in the Bastar Craton, in Bundelkhand Craton, and the Aravalli Craton, because we have plenty of data from the Dharwad Craton and the Singhum Craton. So we need to explore more in these cratons. And these are some of the references, and I would like to express my heartfelt thanks to IISER Kolkata and Ministry of Education, Government of India, for providing me the research fellowship. And I also thanks to all the authors whose publications helped me to do such kind of research work. And thank you so much. Yeah, hello, sir.
Thank you, Aditya. Now I would like to pass to the jury to share their feedback on his presentation. Sir, please share your comments on his presentation. Dr. Gyanendra Pratap Singh, if you want to ask him any question. Okay, so now I proceed to the next participant, Janardhanan Pa, BHU. He will be joining us on the screen. Janardhanan, please start your presentation.
Yes, ma'am. Yeah, Janardhan, you can share your screen.
Yes, sir. Ma'am, is my presentation visible?
Are you giving oral presentation or poster presentation? We have already given it format. Then what does this look like? Some oral presentation? If that poster presentation, that should be in one page, right?
Yes, sir. There's one page only, sir.
Okay, yeah, you can carry on. Okay. Yeah.
So, good morning, everyone. I'm Janardhanan PA from Banaras Hindu University. I'm here to present my poster on the topic recent approach of rubidium strontium method on petrogenetic studies and mantle model. So, as far as the introduction goes, so finding out the origin of a rock is a major thirst in petrology today. The thirst is quenched by many methods, and one such method is this initial strontium method that I'm going to discuss now. The rubidium strontium method, as we know, it is not only used for dating of rocks, but it was also used for tracing the origin of rocks. That is, it is used as a petrogenetic tracer, whether the rock we are finding in the crust is from crust or mantle. And also it is used for modeling the mantle and about the composition of the mantle. So first we see about the mantle evolution data that we get from rubidium strontium method. This diagram given here, this illustration given here is just an idealistic representation of crustal growth from the partial melting of the uppermost mantle. As we can see here, only the upper mantle is depleted while the lower mantle remains undepleted. The depletion of the upper mantle, as we can see in this diagram, the crust grows progressively from left to right. As the crust grows, the rubidium in the mantle goes into the crust. It is incorporated into the crust. This is because of Goldsmith's third rule, which states that rubidium is the ions with the larger size gets concentrated more into the melt, preferentially goes into the melt. So when compared to strontium, rubidium preferentially goes into the melt. As a result, we get higher rubidium in the crust and lower rubidium in the upper mantle. And this results as rubidium decays to strontium. Strontium, as a consequence, is higher in the crust and lower in the mantle. This is given here. We have highest strontium ratio on the crust and highest lower strontium ratio on the mantle. And this model is given by Wilson in 1990. As we can see, the strontium ratio is increasing in the crust as time progresses, and while that of mantle, it is depleting. From this, we can get an idea about the evolution of mantle. So, if a rock is from the crust, it should have high strontium ratio, and if it is from the mantle, it should have low strontium ratio. Now, this is the basis for petrogenetic tracer, and let us dive deep into the petrogenetic tracer. For accurate petrogenetic tracing, we use the initial strontium ratio. The initial strontium ratio is the non-radiogenic strontium present in the rock. It is the strontium that is not generated by the radioactive decay of rubidium. The initial strontium ratio, they do not mass fraction. That is an important factor. It is an important factor. The reason why it is used as petrogenetic tracer. The strontium ratio that we find in the rock is same as the source from which it is derived. As we can see here, the mid-oceanic ridge basalt has low strontium ratio because it is derived from depleted upper mantle. As we saw here, the upper mantle is already depleted during the crustal growth in the geological past. So the rock which is derived from the upper mantle in the mid-oceanic ridge is also depleted in strontium ratio. So if we find a rock in the continental crust with a low initial strontium ratio, we can infer that this rock is from a mid-oceanic ridge. As in other cases, in case of subduction zone, the mantle is depleted here also because it is the same from the upper mantle, but it is depleted. But in case of subduction, the ocean sediments are brought into the mantle, which enriches the mantle region, and hence we get high initial strontium ratio in the island rocks that is formed from subduction zone. This is also the same. The magma may come from depleted upper mantle, but the crustal fragments in it, which is enriched in strontium, may contaminate it and causing high initial strontium ratio in the rocks derived from it. In case of mantle plumes, the magma taps the source from deeper mantle, as we see here. It is not from the upper mantle, it is from deep. As we saw in the above diagram, the upper mantle is only depleted, but the lower mantle remains undepleted. So magma that is tapping source from deeper mantle will have high initial strontium ratio. Next, we are coming to the heterogeneous mantle model. As we see here, different rocks have different initial strontium ratio. If they have these rocks have different initial strontium ratio, then the source should also have different initial strontium ratio. As we can see in this diagram proposed by Zindler and Menzies in 1983, Kettlewood hotspot has higher strontium ratio, while that of mid-oceanic ridge basalts have lower strontium ratio. So initially, what geologists thought was the mantle is homogeneous. Mantle has same composition, but different rock types were generated due to differentiation and different temperature pressure conditions. But the rocks present on the surface had different initial strontium ratio, as we can see from this diagram. So different rocks had different sources. So this led to a confusion that whether the mantle is homogeneous or heterogeneous. The initial strontium ratio gave a clue to it. This is homogeneous mantle model where the mantle is homogeneous through whole mantle convection. If the whole mantle model is correct, then the convection should mix and homogenize the chemically isotopic different behaviors. As we see different initial ratio, if homogeneous model is correct, then this cannot be correct. So the geologists went into a heterogeneous mantle model. As we can see here, the heterogeneous mantle model means different sources in mantle are existing at the same time. Now from this heterogeneous mantle model, a two-layer mantle model was proposed. As we can see here, mantle is divided into an upper depleted level and lower less depleted level. The lower mantle can also be enriched in case of mantle metasomatism. As we can see, the upper mantle is convecting separately and the lower mantle is convecting separately. The lower layer is not depleted because, as we saw above, only the upper mantle is depleted while in the formation of crust. And plumes trap a source from deeper mantle which is undepleted, and hence Kettlewood hotspots have a high strontium ratio. So from this, the mantle model can be constructed, which is with the aid of Rubinian-Sonship method, initial Sonship method. So as far as the conclusion goes, the development of instrumentation techniques has provided more accurate details of the initial Sonship ratio. So with an accurate ratio, we can determine the paleotectonic setting of a rock that is found on the surface. As we can see, as a general rule, if the initial ratio is less than 0.706, then it is derived by partial melting of the mantle, which is a depleted source. If the strontium ratio is greater than 0.706, then we can say it is from either it is from crust, or in case of, or it is from a metasomatized or enriched mantle zone. And coming to mantle, the debate over whole mantle convection and two-layer mantle convection continues even till today. This is a controversial topic, and further research is required to conclude about the composition of the mantle. So I conclude here. Thank you.
Thank you so much, Janardhanan. Now, over to the judges to ask him any question or comments. Dr. Pradeep Kumar Jain, sir, if you want to ask him any question, you can ask. Okay, all right. Now moving to our next participant, Emmanuel Gayan, Ravenshaw University. You can start your presentation. Emmanuel, are you here? Yes, you can start your presentation.
Emmanuel, you can share your screen.
Emmanuel Gayan, please share your screen. Okay.
Yeah, you can start, Emmanuel. It's visible. Your sound is not audible, right?
You are not audible. Sorry, I think he is disconnected or having some network issue. So we will consider him at the end. So now we move to our next participant, Deepayan Rao, NIT Rourkela. I think he is not present. So moving on to our next participant, Lopamudra Biora, Ravenshaw University, Odisha. She will be presenting her poster. Lopamudra, you can start your presentation.
Lopamudra, are you there? Lopamudra? I don't think she's there. No, I think she's not here.
Yes, sir. Okay, so next we have Priyajit Samal, Ravenshaw University, Odisha. Please start the presentation.
Yeah, please you can share your screen. Eh?
Priyajit, you are not audible. Start your on your mic. Priyajit, someone turn on your mic. You are not audible. Yes.
Hello.
Yeah, you can
Am I
continue.
audible? Okay. Good morning. I am Priyesh Samar, Research Scholar of Department of Geology, Ravenshaw University. My topic is groundwater quality studies from the Kulda coal mining area of Sundargarh districts, Odisha. This is the abstract, and then my introduction is water quality is the physical and chemical, biological, and aesthetic characteristics of water which determine the suitability for a variety of issues and for the protecting the health and sustainability of aquatic systems. Mainly in the coal mining areas, the groundwater contamination in these areas based mainly on the overburden dump, tailing of ponds, and this mining allied activities, that is drilling, blasting, and the quarrying. And the mainly the water quality degradation is from the coal mining area, which is caused by the acid mine generation and this release of the heavy metals and the mixing with which is mixing with the shallow water aquifer. When the study area is the Kulda coal mines areas, and this it is a part of E Valley coalfields deposits, and which is belong to the lower Gondwana supergroup of with the Precambrian rocks. And this in this area, the in summer season the temperature rises is to 43 degrees Celsius, and in winter season it is falls down about to 8 degrees Celsius, and the average annual rainfall is 1310 millimeter of the rain. And use the methodology as the collect in the summer season 20 water sample we collect in this Kulda coal mining area and the surrounding areas. And the method is the APA 9995 method is used for the to analyze the water samples, and this which is the result is compared with the guideline of WHO 2008 and the BAS 2012. And this measure ion is that is volumetric titration method is used, and this for nitrate, fluoride, and this sulfate concentration I analyzed in this spectrophotometric method. This is the result, and this is the mainly the total dissolved solids of the area. This is within the permissible limit of this. And this in this diagram, the Piper Tyler diagram, the samples plot on the mostly in the calcium magnesium bicarbonate field, which is indicate the good water quality. And this and from the physicochemical parameter, the water quality index, that is WQI, is calculated. It is ranges from 20 to 80, which indicates there is excellent to good quality water. And this that's a USSL diagram. It is indicate the mostly the sample falls on the C1 S1 field and C2 S1 field zone, which indicates low to moderate salinity and low to sodium hazard type water type. And the Scaly ratio is values varies from 0.18 to 0.96, which is less than 1, and it is suitable for the irrigation purpose. That the conclusion. Hello. This based on the physicochemical parameters, the water in the study area, the water is suitable for domestic and irrigation purposes. From this present work study, there is no adverse impact on the water quality has been reported due to the coal mining operation in this area. I am thankful for my guide and co-guide and my colleagues for their guidance and support. Thank you.
Thank you so much, Priyajit Samal. Now we have with us our next participant, Vasanta Raj, Anna University, Segundi, Chennai. You can start your presentation. Vasanta, start your presentation.
Make me as a presenter.
What's your name?
Vasant.
Oh, Vasant.
Rasan, but here there is nothing. Acha, Vasant. Okay, okay. Okay, you can present.
Okay, next we have Sulendra Mahto, IIT Bhubaneswar.
Why next? He'll share his slide. Just wait. He's sliding. He's sharing his slide.
Yes, sir.
Yeah, Vasant, you can carry on. Vasant, are you there?
Yes, sir. Yes,
Sir,
sir.
I think
1 minute. Sir, is my slide is visible?
You just
Hello.
yes, start your presentation. Yes, you are visible.
Okay, ma'am. So, good morning to all. So, today my presentation is about the spacecraft and the most advanced instruments that are used in the Mars missions. So, I am Vasantharaj from Anna University CEG. I am a MSc student in Chennai. So, in the recent advanced technology, there are many countries are focusing on Mars to do to analyze what are the surface features that are present in the Mars, to know the subsurface anomalies, to do any sort of valleys, mountains, some sort of features they have to understand. For that, they can use a lot of more advanced technologies for to know get more advanced details of that particular area, and also the Mars surface and subsurface also. So the first we are going to talk about the Mastercam. There you can see in the left side, it is the Mastercam instrument. It is very much useful to take high resolution stereo images from the Mars. There are a lot of images that are taken by this Mastercam. In the further future missions also, this Mastercam going to play a crucial role in the Martian missions. And the next instrument we are going to talk about, the Mars Environmental Dynamic Analyzer. It's a something new technology by the NASA's Perseverance rover mission. It's something we can able to analyze the environmental dynamics, because Mars is a planet nothing but it's all wind activities are more commonly happen in the Mars. There are a lot of dust storms that happen in the Mars. For that environmental dynamics, these MEDA, Mars Environmental Dynamics Analyzer, is very much useful to get some valuable data about the Mars due to very low gravitational field. So there is really hard to launch or move a drone in Mars. So for that environmental purposes, they use the MEDA analyzer. So next instrument we are going to talk about is the MOXIE. So MOXIE is nothing but a Mars oxygen in situ irradiation experiment. So it's a MOXIE. It's nothing but it's like a human being that we can consume carbon dioxide, we can emit oxygen, and this instrument is particularly used in Mars to break down the CO2 and convert the CO2 into oxygen by using the MOXIE. It is the most advanced instrument that are used by the Perseverance rover to, because a Martian atmosphere is something that 96% of Mars atmosphere is consist of carbon dioxide, 96%. So in order to get humans there, for that we need oxygen. For that purpose, they use the MOXIE, Mars Oxygen ISRU experiment, to convert the carbon dioxide into oxygen. The next instruments we are going to talk about the
PAXL, the planetary instrument for X-ray lithochemistry. This is a more advanced technology used to this. It acts like a telescope. I can be able to rover anywhere in the Martian surface. If we want to know a particular rock type and what are the elements that present in that rock, this PAXL planetary instrument, due to X-ray diffraction, they can able to hit the laser beam in that rock and emit the atoms that are present there. Of course, there is an emission there. Of course, there is a radiation that produced by that atom. So, by observing that radiation, we can able to interpret some sort of data about the rocks mineralogy and what the most abundant element that present in that rock. For the purposes, they use the PIXL instrument. And next, we are going to talk about the RIMFAX. RIMFAX is nothing but the radar imager for Mars subsurface experiment. These instrument something resembles the SHARAD, which was taken by the Mars reconnaissance orbiter in a few decades before. The SHARAD also is a subsurface shallow radar. We can able to interpret the subsurface. They mainly focusing on the polar caps and ice. For the same purpose, it's more little bit advanced when compared to the SHARAD, the RIMFAX. RIMFAX is nothing but they can emit the radar signals into the particular subsurface. We can able to interpret a lot of details about the subsurface areas. In recent times, they are interpreting a lot of details about the subsurface on the Mars to know what are the icy surface, to any sort of water or past lakes that are present in that environment. So the next final instrument we are going to talk about is the Sherlock. Sherlock is nothing but is a scanning habitable environment with the Raman luminescence for organics and chemicals. The Sherlock is it's also an advanced technology to mainly used for the organics, any sort of microorganisms that are present in the Mars. By using this instrument, we can able to interpret some sort of data. And also, this instrument is something very much useful in methane detection of methane on the Mars. Also, in the India Mars mission, in the Mangalyaan one, they used this Mars detection of methane on the Mars. So it's the most advanced technology. Sherlock is nothing but is a scanning habitable environment with the Raman luminescence for organics and chemicals analysis. So by using this instrument, we can able to detect a lot of new and most advanced details that are present in the Martian surface and also in the subsurface. Lithology, of course, mineralogy, what are the features, there are terrain features, mountain features, in the more advanced data and high resolution stereo images also we can able to get by the MASTCOM instrument. So by using this advanced technology to get some more advanced details, due to them say high resolution stereo images from the Martian surface and from the subsurface, also we use the RIMFAX instrument, also radar images. We can able to interpret a lot of details. In future Indian Martian missions also, this is the most advancement, and they must have used these sort of payloads into the Mars to get some more advanced details on the Mars. Thank you.
Thank you, Vasantha. So now I move to the jury if they have any questions to ask him. All right, now we move to our next participant.
I have one question from Vashant. Which of these devices has been used in the Chandrayaan 2? Which of these devices has been used in the Chandrayaan 2 for the Mars mission?
In the Mars mission, particularly in India, they use a Mars methane detection to detect the methane presence in the Martian surface, and also use some more advanced resolution cameras for taking some high resolution images also in Mars. So these are only 5 payloads that are used in that Indian Martian missions.
Not in the Chandrayaan 2. These were used earlier, right?
Yes, sir. In 2013, there's some sort of payload that used in the India to get some detailed manner in the Martian surface.
Okay, but I'm not to say I'm also a student of this college, but so I was asking some doubts regarding that. Okay, thank you, bro.
Thank you.
Thank you so much, sir. Now we'll proceed to our next participant. Next we have with us Sulendra Mahto, IIT Bhubaneswar. Sulendra, please start presenting your poster.
Okay. You can share your screen, Sulendra. Now you
Is
are
it
presenter.
visible, sir?
Yes, it is visible and you are audible too. It's fine. Okay, start. You can proceed now.
Okay. Good afternoon, everyone. Myself, Sulendra Mathur from Indian Institute of Technology, Bhubaneswar. Today, I am going to deliver a short poster on machine learning in geoscience. So let's start with abstractions. Machine learning is a subdivision of artificial intelligence based on the biological learning process. The machine learning approach deals with the design of algorithms to learn from machine readable data. Machine learning covers main domains such as data mining, difficult to program applications, and software applications. It is a collection of a variety of algorithms, for example, neural network, support vector machine, self-organizing map, decision trees, random forest, cache-based reasonings, genetic programming, etc., etc. that can provide multivariant, nonlinear, non-parametric regressions or classifications. The modeling capability of the machine learning based method have resulted in their extensive application in science and engineering. Herein, the role of machine learning as an effective approach for solving problems in geoscience and remote sensing will be highlighted. So, I am going with introductions about the machine learning. Machine learning is an effective empirical approach for both regression and or classification of nonlinear systems. Such systems can be massively multivariant involving a few or literally thousands of variables. In machine learning, a comprehensive training dataset of example is constructed, covering as much of the system parameter space as possible. Typically, a random subset of the data is put aside for a complete independence validation. Machine learning is ideal for addressing those problems where our theoretical knowledge is still incomplete, but for which we do have a significant number of observations and other data. In ideal world, if we had complete theoretical understanding, machine learning would be superfluous. Machine learning has proven use of a very large number of applications in many parts of Earth systems, like in land, ocean, and atmosphere, and other beyond from retrieval algorithms, crop disease detection, new product creations, bias corrections, code accelerations, etc. The main type of machine learning algorithms commonly used are artificial neural network (ANN), support vector machines (SVMs), self-organizing map, decision trees, ensemble methods such as random forest, cache-band reasonings, neurofuzzle, genetic algorithms, multivariant adaptations, regressions, spinels, etc., etc. Now I am going to talk about the methodology. The machine learning algorithms are universal approximates. That is, they learn the understanding behavior of a system from a set of training data. Another interesting feature of machine learning based technique is that they do not need a prior knowledge about the nature of relationship between the data. The application of machine learning may be categorized into three areas. The first one is the systems deterministic models is compulsory, expensive, and machine learning can be used as a code acceleration tool. The second one is there is no deterministic model, but an empirical machine learning based model can be derived using the existing data. And the third one is classification problems. As mentioned before, Machine learning includes a variety of algorithms like ANN, SBM, SOM, and DT. Over the last decade, there has been considerable program in developing machine learning-based methodologies for many of earth science applications. Some of these studies have received a special recognition as a NASA Euroscience highlights and commendation from the NASA MODIS instrument team. ANN and SBMs are the most commonly used machine learning technique for dealing with geoscience problems. Among main subset of machine learning application of genetic programming in the geoscience and remote sensing domains are very new and restricted to a few areas. Despite the good performance of ANS, SBMs, and many of the other machine learning methods, they can considered as black box model. That is, they are not capable of generating practical predictions equations. GP is considered as an effective approach to deal with this issue, and GP uses the principle of Darwinian nature selections to generate computer programs for solving a problem. In fact, GP is a specialization of GA, where the enclosed solutions are computer program rather than binary strings. A notable feature of GP and its variant is that they can produce prediction equations without a need to predefine the form of existing relationship. The majority of applications of GP focus on the behavioral characterizations of rock mass. The other few studies use GP as a tool of interpreting the remote sensing data. It is worth mentioning that there are some other studies, mainly on the applicability of GP for analyzing geotechnical engineering problems such as liquefaction phenomena, ground motion parameters, or ground movement pattern. The machine learning based techniques are increasingly used for interpreting the remote sensing images, that is RSIs. Conversely, from the other machine learning method, there are few GP based studies in the field of remote sensing technique. Some typical examples are estimations of typhoon rainfall over oceans using multivariant meteorological satellites data, monitoring reservoir water quality using remote sensing image, mapping of base level deposits, image thresholding for landslide detections, and soil moisture distribution analysis. RSIs are widely used as valuable tools in different real-world applications. In the context of agribusiness application, a major challenge is recognitions of crop type. The cope with this issue, Dos Santos et al. And in 2010 proposed a new GP-based approach for automatic recognitions of coffee crop in RSIs. They combine text and spectral information enclosed by image description. In figure 1 shows the step of the proposed classification process. As it is seen, this approach can be divided into two phases. One, the image description, and the second is image classification. The first phase includes the step 1 to 3, which focused on the image contents, and the remaining 4 steps belongs to the image classification process. GP has been used by Dos Santos et al. 2010 to identify relevant partitions by combining the similarities provided by descriptometers. Now I am going to discuss some geoscience applications for machine learning. First one is detecting objects and events. Detecting a spatial and temporal pattern in climate data can help in tracing the formation and movement of objects such as cyclone, weather fronts, atmospheric rivers, and ocean eddies, which are responsible for the transfer of precipitation, energy, and nutrients in the atmosphere and ocean. Machine learning algorithms can enable their automated detections from data with improved performance using pattern mining techniques. The second one is estimating geoscience variable. An important category of geoscience problems where machine learning can contribute is to estimate physical variables that are difficult to monitor directly. For example, methane concentrations in air or groundwater seepage in soil. Using information about other observations or simulated variables, for example, supervised learning algorithms can be used to produce estimates or ecosystem variables such as forest cover, health of vegetation, water quality, and surface water availability. The third one is long-term forecasting of geoscience variables. Forecasting long-term trends of geoscience variables such as temperature and greenhouse gas concentration ahead in time can help in the modeling future scenario and diversing earlier resource planning and adaptation policies. From a machine learning perspective, the problem of forecasting can be treated as a time series regressions problems where the future conditions of geoscience variable have to be predicted based on present and past conditions. Now the last one is mining relationship in geoscience data. The periodic changes in sea surface temperature over Eastern Pacific Ocean, also known as the El Nino Southern Oscillation, and their impact on several terrestrial events such as floods, drought, and forest fire. A common class of relationship that is studied in the climate domains is teleconnections, which are pair of distance regions that are highly corrected in climate variables such as sea level pressure or temperature. One widely studied category of teleconnections is dipole, which are pair of regions with strong negative corrections. For example, the ENSO phenomena. One of the first machine learning attempts in discovering relationship from climate data is a seminal work. In this work, graph-based representation of global climate data were constructed, in which each node represents a location on the Earth and an edge represents the similarity. For example, correlation between the climate time series observed at a pair of locations, dipoles and other high-order relationships. For example, tripole involves triplets of regions could then be discovered from climate graphs using clustering and pattern mining approaches. Another family of approach for mining relationship in climate science is based on representing climate graphs as complex network. This includes approaches for examining the structure of climate system, studying hurricanes activity, and finding communities in climate networks. And the final, my conclusion is machine learning focus on the automatically extractions of information from data by computational and statistical method. Herein the feature of the machine learning technique for non-parametric regions and classification purpose are outlined. The machine learning's applications are very diverse and includes different themes such as trace gases, aerosol products, vegetation includes ocean products, characterizations of rock mass, liquefaction phenomena, ground motion parameters, interpreting the remote sensing image, etc. And my acknowledgement, and there are some references, and I would like to thanks to all of the faculty members and the HOD of PK Memorial College and all the authors from where I took the materials. Thank you.
Thank you, Sulendra. Again, I would request to the jury team to ask him any question if they want.
Yeah, Sulendra, what you have done up to now means what are the different techniques you have used and you have interpreted. That is your means your view. Sulendra, are you there?
Yes, sir. Yes, sir.
Yeah, so now what I am asking that means what are the different techniques you have used and you have interpreted.
Sir, can you say once again? I can't hear you.
Okay, what are the different techniques you have used and you have interpreted?
Sir, practically I haven't to do anything still now, like whatever I discussed.
Then you are presenting others, right?
Yes, sir.
And what is your conclusion? Just tell me in one sentence. What is your conclusion? Means
Yes,
what you can do this in future?
Sir, in future we can use the the things where we can't go, but
Not we can means I can use.
Oh yes, sir. I will try to discover all that things where we can't go and we didn't reach that place. But in upcoming days, I will try to develop some techniques where we can go and we can observe all the things from that area and observe all the data and discover new things.
Okay, thank you for such a nice presentation. And Dr. Devashish, you can ask one question. Dr. Devashish.
Sulendra, yes,
Yes, sir.
sir. Sulendra, you have talked regarding many of the techniques which have been used by ML techniques. Okay, so
Yes, sir.
do you know what is the basic of the ML? Means how you can go for any of the technique to decipher on the best of the machine learning. Can you please tell me what is the genesis of the ML? What actually you are doing and what actually you will be doing? I am really confused because people are always taking that this has done this and so also we can do this. Yes, it is possible. Even you can predict the earthquakes, even nothing is impossible by ML techniques. But can you please tell what is the basis? Means on which basis you want to develop and what you want to actually develop, please.
Sir, actually, there are many techniques for the different types of interpretations. Like
My
for the
so Surendra, my question is totally pinpointed. My question is what actually you want to do and how you can start. Many techniques we
okay.
don't because many techniques are there, you know.
Yes, sir. Yes, sir.
So only by
Like sir,
talking about many techniques is not going to give us a ample opportunity. Means you want to do what and how. Please tell.
uh, sir, till now I didn't think about that, but in future times, like we can't go inside the earth. Means ki,
Huh?
we can't go out inside above than the 10-11 kilometer or above the course. But I means I just want to go inside the earth and
You want to
do.
go inside art?
Yes, sir.
How is it possible, Surendra?
Sir,
No, no.
I will
Look,
try to
exactly.
develop the
You are a
technique.
MSc student. You are a MSc student or you are a research scholar?
Sir, I am a MSc first year student.
Okay, okay, it's great. It's great. You are not so much towards the research. I would suggest you that please, whatever the technique you are talking and whatever the things you are talking about, please go through
Yes, sir.
them, read literatures, and what is the validity of these studies you have to do. Unless and
Yes, sir.
until there is nothing to come out. Okay, okay. You
Okay,
take
sir.
care.
Okay.
Bye.
Thank you, sir.
Thank you so much, sir, and thank you so much, Sulendra, for your presentation. Next, we have with us Akash Kumar Malik, Banaras Hindu University. You can start your presentation now. Akash, are you present?
Yes, ma'am.
Akash, you can share your slide.
Start sharing your screen.
Yes, ma'am. Just a minute.
Okay, all right.
Yeah, are you facing any problem? Just you can
Hello?
auto. Yeah, it's coming. It's coming, but you can rotate in landscape
Is it
mode. You
visible, sir?
can. Yeah, it's visible. Yes.
Okay, sir. Yes, sir. Hello, good morning, everyone. I'm Akash Malik from MSc first year IIT Bhubaneswar. I'm going to present the poster about the geology modeling or geomodeling. First of all, the process of geological modeling or geomodeling denotes the construction of 3D representation of relevant geological structure or any surface or topographic picture of Earth. It can basically be understood as the extension of geological maps into three full dimensions. Actually, it is the integration of some parts of geology, just like structural geology, sedimentology, stratigraphy and diagenesis and paleoclimatology. It all together forms a model. We can create a model by using integrating these all geological criteria as called as geological modeling, and we can get any kind of information according to our preference or needs. The technology of geomodeling actually started in 1970s with basic programming language called as Fortran. In that time, geomodeling consists of only of automatic 2D cartographic techniques such as contouring. There is no 3D modeling, only 2D automatic cartographic was present. Later on in 1980s, the 3D dimensional geomodeling is introduced, which gave birth to a new generation of geomodeling with advanced softwares and technologies. And in 90s and 21st centuries, it becomes very advanced and applied very possible to get maximum benefits by the technology. Geomodeling technology is applied for various purposes such as managing natural resources, identifying natural hazards, uh, using in exploration of oil and gas fields, exploration of groundwater aquifers, and ore and mineral deposits. For example, in the oil and gas industry, realistic geological models are required as input to reservoir simulator programs, which predict the behavior of the rock under various hydrocarbon recovery scenarios. A reservoir can only be developed and produced once. Therefore, making a mistake by selecting a site with poor condition for development is tragic and wasteful. Using geological models and reservoir simulations allow reservoir engineers to identify which recovery option offer the safest and most economical valuable for the exploration. Another example is mining field. One of the biggest gaps in mining industry geoscience is between our understanding of ore deposit formation and application in resource estimation. Significant advances, including imaging and analytical methods, has given better understanding of interactions between hydrothermal fluids and host rocks. Advanced geostatistical methods and improved hardware and software capabilities allows rapid processing and interpretation of huge amount of drill hole data. However, there is something a significant lack of communication between geoscience and geostatistics, resulting in reduced confidence in resource classification and sometimes poor business decisions, which will cause many loss of us. This is the opportunity and future of geological modeling. By using geological modeling, we can apply the geological modeling technique to it, which will give us the actual data and will help us for our purpose and exploration of any kind of mining purpose. Now we will discuss about the techniques of interpretation. Geomodeling needs a lot of common technologies such as software and computational geosciences. The graphical user interface generally consists of one or several 3D and 2D graphics windows to visualize spatial data, interpretations, and modeling outputs. Such visualization is generally achieved by exploiting graphics hardware. Aerial photography, remote sensing, GIS is also a widely used tool to manipulate geological data and collecting the input data for creation of a model. That means we can collect the data by GIS technology and aerial photography technology uh, and and use as input in the software to get or create the modeling of particular area for particular population. First of all, we have to collect there are several steps for creating a geomodeling. We can take an example of creation of a topographical geomodeling. First of all, we have to collect the data of elevation, relief, lithology, vegetation, water content, and all other surfacial features before creation of a geomodel of an area or topography. Let us take an example of topography model. First, we have to put the point data collected by the image, sensors, or by satellites into advanced softwares like Leapfrog or many other softwares are available there. Then we have to set the XYZ coordinates in according to the direction, then set the resolution of the model in according to our purpose of use. High resolution model will give detailed information about the area, and the low resolution will give not much details. It will become very smoother. Then the next step is then we have to choose the basic lithology, in which we have to choose the colors which will represent various lithology on the geological model in according to the real surface or topography. Then the next step, then we have to do work with model extension, which involves choosing the extension or area which will express by the model. We can crop any part of the surface and create model for only the important part of the topography. After the then the model will created and saved as 5 subfolders, just like boundary, fault systems, lithology, and output volume. In the boundary, we can edit the extension of the model. We can manually control the extension of the model we have to get the particular area of the particular topography in the
The
fault
audio
system.
is not coming for that participant.
Represents the, excuse me. Hello, I'm Sir. Sir, am I audible?
Yes, please continue. Yes, please continue.
Okay, sir. Then the next folder is lithology, which represents various lithology as various colors in the three dimensional model. Then is the surface chronology, which refers to the chronology of the surface area. Output volume, it is a total output or finalized model of the topography that we have been taken and created. And then we'll come to the conclusion part, or the why we take this particular subject, because geomodeling is using and applied in outside the laboratory, and many mapping programs and study of various topography and surface of the earth. We can also use in the laboratory or in the room during let's say an example of current situation. During this pandemic period, all the classes are running in the online mode. Even the practicals and field visits are also occurring through online media, and in this mode we are able to see only the pictures and moreover the videos. We can see but cannot observe in that way, particularly the clarity or the better structures or important features by the image and video. It will be more efficient if we use the geomodeling concept to do such things. Let take an example of a hand specimen of rock. The pictures we can see the color, size, and shape, but it will be harder to get information about the grain size, particularly the phylum, the small scale cleavages, textures,
Yes, yes,
inclusions, and
Akash,
also we
Akash.
can.
Yes, yes, Akash.
Yes, sir.
May I disturb you a little bit? May I restrict
Yes,
you?
sir.
Okay, so we just got to know that what actually you are willing to do at this. Basically, you are talking about the modern geomodeling. Okay, now you are in the conclusion part, isn't it?
Yes, sir.
Let's hope you have
Yes,
finished. Okay. So thing is that
yes,
I have little suggestions. You are a MSc student, and I have little bit suggestions for you. Whenever you are preparing some posters, okay, don't write so much.
yes, sir.
Always try to give some
Okay,
graphics, or always try to make some points which are really valuable. Don't write so much in your poster. Okay,
That is the one thing. And second thing is that what valuable aspects you are actually trying to, can you please summarize what valuable aspect you want to tell? Geomodeling, modern geomodeling. What is modeling? You are talking about the Fortran. Are you know about the Fortran language? Anything?
So the basic programming language is Fortran.
Yeah, so many languages are there and many new methods and many new geomodeling have been happening. But I can see there is nothing so much like a particular model name is being there. Okay. So please go through. You are MSc first year students. I suppose that you will definitely develop yourself in this geomodeling category. It is really happy for all of us to see that you are going in this field. Please go through the different literatures and please be very much develop your caliber in the modelings, okay, in different languages. It will really help you. Okay, this is from my side. Dr. Sagar,
Thank you.
over to you.
Yes, thanks for such a nice. Just one question I'll ask. What is the what you will do in future with this? What you have thought? What you will do in future?
Sir, in future, I want. Yes, sir.
Yeah. Tell.
Yes, sir. We can develop more the geomodeling by using the GIS technology and GPS technology, and can get many more information about any particular topography or area, and we can use and apply to the, many exploration programs to get benefits from it.
Okay, and okay, thanks. Up to now you have not did you did not do anything, right? Up to now you are just following others.
Yes, sir.
Now
Yes.
you have planned to do in future.
Yes, sir.
Okay, then thank you, Akash. Then we'll proceed for our next
Yes,
participant.
sir. Yes, thank you so much, sir. Now we have our next participant, Pranati Hansda, Dhanaridhar Autonomous College, Kyonjar. She will be joining us on the screen. Pranati, are you there? Please respond.
Hello, sir.
Yeah, you can share your
Hello?
slide.
Yes.
Yeah, you can share your slide.
Yes, you are. Presentation.
Dr. Sagar.
Yes, sir. Yeah.
Sagar.
Yes, I'm here.
Yes, Sagar, can we interpret the students in between their presentation? Is it or not?
Sorry.
Can we restrict them within and we can ask some questions within their presentation, or is it good?
Yeah. No. We can restrict them in 2 to 3 minutes, like that, 3 to 4 minutes.
Yes. And within the presentation also we can ask questions, no problem.
Yes. Yeah. You can restrict.
Okay.
Hey, Jonathan, you can complete within 3 to 4 minutes, right? Then we'll ask questions.
Okay, sir. Okay, sir. Sir, is it my screen sharing?
Okay, it's okay. You can start.
Sir, is it sharing now?
You already your screen.
Okay. So my name is Pranati Hansda. I'm from the Dhanidhar Autonomous College, Kyonjar, and I'm representing the poster presentation. The topic is volcanism. And as for volcanism, it is the eruption of the molten rock or lava onto the surface of the planet. And the term is coined by Canadian geophysicist John Puzo in 1960s, suggested that chains of volcanic islands formed from the movement of the sea floor over relatively stationary hotspots in stable centimeters of mantle convection. Then volcanoes are created by internal forces within the earth that cause heated melted rock magma to rise to the surface. For collecting in magma channels, some of the magma eventually pushes upward through cracks, vents to the Earth's surface. As the magma reaches the surface, it loses some of its gases. Sorry, sir. And turns into lava. Volcanoes are created by the release and buildup of lava and other materials. There are three types of volcanoes, that is shield volcanoes, cinder cone volcanoes, and composite volcanoes. Volcanoes look like dome-shaped mountains. The mountain is formed when the lava spills out and gradually creates a dome-shaped mountain. For example, we have keloid at the right, was the site of nearly continuous activity during 19th century and the early part of the 20th century since 1952. There have been
The
34
slides are
eruptions
not
shaped as
visible. The slides are not visible.
slide. Sir, it's only one slide.
Okay, from
Is it
your
visible now,
slide,
sir?
Yeah, please go on. The slide is visible, please.
Okay, okay. The second is cinder cones that looks like cone-shaped mountain. A material called tephra cinder erupts and forms a cone-shaped mountain. For example, Puyucaville on the southeast flank of Molana Cave volcano. Then the third comes composite volcano, that is, or it is called as stratovolcano. Have wood, tephra, and lava material erupting from it. The materials layer themselves and form a huge cone-shaped mountain, composite volcanoes. Then volcanic materials ultimately break down and weather to form some of the most fertile soils in Earth, cultivation of which has produced abundant food and fostered civilization. The internal heat associated with young volcanic systems has been harnessed to produce geothermal energy. The volcanoes have been influenced a man in a different way, that is release of intense pressure safety value helps in studying interior of the earth, fertile black soils, many valuable minerals, and geothermal energy, crater lakes used for the irrigation. Although volcanoes have the reputation of being very dangerous, there nevertheless are advantages of living near a volcano. Volcanoes provide resources for energy extraction, also called geothermal resources. Heat from the earth crust is being converted to energy. The big advantages to this type of energy that it is very clean and the resources are nearly inexhaustible. When a volcano erupts, it throws out a lot of ash. At short notice, this ash can be very harmful to the environment, but on the long term, the ash layer, which contains many useful minerals, will be converted to a very fertile soil. Nearly everywhere volcanoes are located, people use the rich soil for farming. A big economical advantage of volcanoes is that they generate tourism. A country such as Hawaii is getting a lot income from tourism. There is some economic value of volcanoes. Ammonium carbonate, sodium carbonate, and boric acid are derived from steam and hot water. Hydrogen sulfide gas oxidized to form water and sulfur, which is responsible for larger sulfur deposits. Truck rock is used to build roads. Pumice is used for grinding and polishing. Tuff is used as building stone. Then we have that there are 6 ways like how volcanoes benefits Earth, our environment, that is atmospheric cooling, land formation, water production, fertile land, geothermal energy, and raw materials. Okay. There are some pictures of the recent volcanoes, which is one is
Sorry,
Paneer
your slide.
volcano, the most active volcano in the world, with a record of long-lasting eruptions since 1983. Then we have Merapi volcanoes, one of the most active and most dangerous volcano in Indonesia. Then it was a early volcano. I have an example, that is volcano at Pilot Knob. The volcano formed 18 million years ago when Austin was underwater and was several thousand feet in its prime. It is now 711 feet above sea level, or 100 and 150 feet above the surrounding terrain. The limestone surrounding it, in which most resistance to erosion than the volcanic dust, which is the material that fell from the volcanoes during the eruption. Over geological time, volcanic eruptions and related processes have directly and indirectly benefited mankind. Volcanic materials ultimately break down and weather to form some of the most fertile soils on Earth. Then the internal heat associated, which is used for cultivation, which has produced abundant food, and the internal heat associated with young volcanic system has been harnessed to produce geothermal energy. Most of the metallic minerals mined in the world, such as copper, gold, silver, lead, and zinc, are associated with magmas found deep within the root of extinct volcanoes. Volcanoes have blindsided humans for millennia, leaving entire cities at the whim of the devastating eruptions. But compared to other forms of natural disaster, volcanoes actually offer a variety of quiet clues leading up to their destruction. Now, new developments in volcano monitoring system allow scientists to sniff out, forecast, and plan for eruption with more precision than ever before. The visualization also gets viewer follows along as new sensors are developed. These sensors continuously measure carbon dioxide, sulfur dioxide, and water vapor coming out of the volcanoes and are placed within the large boxes and buried underground with antenna on the surface. In recent years, advancement in electronics have made them more precise and operable, allowing scientists to use them more prevalently around the world. Gas sensors help forecast eruptions because as magma rise up, the resulting release of
Your
pressure
time is over,
over
right?
the unrocks.
Your time is over.
Hello, sir?
Your time is
Yes,
over.
sir.
We are out of time. Now we are out of time. Just
Okay,
we
sir.
conclude. Just last sentence. Just you can conclude.
Yes, sir. Wait, sir. So lastly, I will conclude that volcanism offers many aspects like they provide rocks to study and they provide us many minerals, and it's also helps studying some geological activities happening around. So that's all I will conclude. Hello,
Uh,
sir.
yes, thank you, Pranati. I would like to ask the jury if you have any question for her.
Yeah, Pranati. So, do you think that the
Yes, sir.
volcanism is a good thing for the social people, the society, or is it a bad thing for the society?
So it has both advantages and disadvantages. Obviously, it disadvantage is that people staying near them will be affected through volcanism. And on the other hand, it has advantages because it has provided with various minerals and rocks, which is now we are using in preparing many things around us. So yes, it has both advantages and disadvantages. So I'll say it is both beneficial, also harmful for the society.
Okay. So, which is more? Harmful is more or good is more? Oh, okay.
But
Anyway, can you please tell in
if
one
we
line?
take precautions,
Yeah.
hello, sir.
In one line, please tell me what is the mechanism of the
Yes.
volcanism? Mechanism of
Volcanism is how it
volcanic
is formed.
eruption. Yes, how the volcano erupts.
Okay, sir. Volcanism, it erupts by there are many activities happening around like moving of plate tectonics or subduction taking place. Then when plate is subducted under another plate, then the remaining things which is like in the between the two plates,
Do you know about the mental
then
convection
the
cycle?
material between them, there's
Do you know about the mental
hello,
convection
sir.
cycle? Do you know about mental convection cycle?
Not exactly, sir. I just
Today we
started
have
reading
discussed.
volcanism.
Today also I have discussed regarding this. It's very good to see that you have developed some new interest in volcanism. It is one of the growing aspects in geosciences as well as in geophysics. Please go away
Yes,
and
sir.
search many of the literatures. Okay, it is a new and
Yes, sir.
fascinating topic.
Yes, sir.
I hope you can develop your new
Thank you, sir.
interests. Okay, and you please carry on your research work. Okay, thank you. Take care. Bye bye.
Thank you, sir.
Thank
Thank
you.
you very much, sir.
So, before moving to our next participant, one more thing I want to say is that please finish your presentation within 5 minutes. We are already running out of time. Now we have Sujata Kumari, St. Columbus, Hazaribagh. She will be presenting her presentation. Sujata Kumari, please turn on your mic and start your presentation.
Is my screen is visible?
Yes, carry on.
Yeah. Hello everyone. Good afternoon to all of you. This is Sujata Kumari from St. Columba College, Hazaribagh. My topic of presentation is solar radio signal. Solar radio signal. So what
Sorry
is
to
solar radio signal? Am I audible? Hello.
If your slide is not visible, please
Yeah.
start.
My topic of representation is solar radio signal. A solar radio signal is a radio waves that are naturally produced by the sun. Solar radio and my topic solar radio signal is based on the theme innovative approach and recent advances in the field of geology. My presentation reflects the solar radio signal that could be used to monitor melting ice sheets, which is a very low cost and low power and widespread monitoring of ice sheet evolution and contribute to a sea level rise. And we know in recent days and we know the recent days that in Greenland, the researchers have successfully tested the on a glacier. Wait. Am I audible? Uh, According to the researchers, this lead to a more pervasive alternative and less energy efficient compared to the current method of collecting data. So in Greenland, I've put it one map of Greenland and Antarctica. They are the two largest area of island which cover the largest ice sheets, the Greenland and the Antarctica. Now, I just come to our introduction part. A team of geologists and electrical engineers show how radio signals naturally emitted by the sun and can be turned into a passive radar system for measuring the depth of ice sheet and successfully tested it on a glacier in Greenland. And in recent days, the Greenland experienced a massive melting in heat wave with enough ice vanishing in a single day to cover the whole of Florida in 2 inches of water. The advanced may offer a large-scale, prolonged, and insight into a melting ice sheet and glaciers, which are among the dominant causes of sea level rise, threatening coastal communities around the world. The sun provides a daunting source of electromagnetic disarray, which is emitted by the massive ball of gas arrive to Earth in a wide spectrum of radio frequencies, making it a powerful tool for monitoring ice and polar changes on Earth across the solar system. Now I put it the one figure that is solar signal stored glacier of Greenland, where researchers showed that a battery-powered radio receiver with an antenna placed on the ice can use the can use. Now come to a methodology. The what method should how they what is the procedure of doing? So airborne ice penetrating radar is the primary current means for collecting widespread information about the solar subsurface, which system transmits its own active radar signal down through the power receiver with an antenna placed on the ice to detect the sun's radio waves as they travel down to the earth through the ice sheet and to the subsurface. Instead of transmitting its own signal, the system uses the naturally occurring radio waves that are already traveling down from the sun, a nuclear power transmitter in the sky. Let's go to the indispensable, that is the advantages of the solar radio signal. So, monitoring of ice sheet under climate change and exploring icy moons at the outer planets are both extremely low resource environments where they really need to design elegant sensors that don't require a lot of power and it is very cheap in cost. And second one is the without the need to transmit its own signal, the team system was considerably uses less energy intensive than its active counterpart. It could even run off batteries, potentially facilitating the creation of practical continually operating ice monitoring network if the hardware can be suitably miniatured. The researchable proof concept uses a battery powered receiver with an antenna with an ice sheet through the ice sheet and to the subsurface. The solar radios were having a several advantages over traditional radios. One being the elimination of need of having batteries for the operation, which made the radios ideal and low cost. So this is the thing from my side. Hope you like it. Thank you.
Thank you, Sujata. Now I would ask the jury to ask any question from Sujata if they have. Sir, if you have any question, you can ask. All right, next we have with us Emmanuel Gain, Ravenshaw University. He will be on the screen. Emmanuel, please start your presentation. Emmanuel, are you present?
Yes, yes. Please enable me to see the screen.
Yes, you can share your screen.
Share your screen, Emmanuel. Now.
Just 1 minute. We have some network problem. Just we are doing that.
Okay.
Hello. Hello, is my screen visible?
Yes, yes, it's visible. You can carry on.
Okay. Very good afternoon to all the respected dignitaries present here, to all my seniors, my colleagues, and my dear friends. A very good afternoon. And my topic is on the geochemical effects of the hot spring on the groundwaters of the Niagara district, Odisha. Okay. So, as we know, groundwater is the basic need for every living being on this earth. But this groundwater is facing a major contamination issue nowadays, right? And this contamination issue is mainly because of the lot of contaminating ions such as fluorine, then we have nitrates, then sulfates, then arsenic. So these elements, what they cause, they enter into the groundwater and deteriorates its quality day by day. And according to the aqueduct water atlas, in the world ranking, there have been 17 water stressed countries. Okay, and India ranks 13th in them. And major population of India, about 85%, they depend on this groundwater only. It's a major concern for us to maintain the quality of the groundwater. And this fluoride solubility in groundwater is more enhanced when we'll find any geothermal water in that area. Okay, so what is this effect of this the geothermal waters on the groundwater is shown in this presentation. And going to the introduction, we have the deteriorating quality of is of the major concern nowadays, because around 1.6 million people in India, they are facing health issues related to this groundwater only. Okay, so what happens as the groundwater travels on its way of transport, it reacts with the adjacent country rocks. Right, and in this case, what happens? All the soluble minerals, water soluble minerals, which contain fluoride in them, like the apatite, then we have fluorapatite, then cryolite, right? So ceolite, they all enter into this groundwater, and they increase the fluoride concentration in groundwater. So there is a limit to this fluoride concentration in groundwater as set by the WHO 2012, and it is 1.5 milligram per liter. Right, but it gave a flexibility to all the nations to set their own limit depending upon the concentration of fluoride in their area. So, beauty of Indian standards in 2012, they have brought down the limit to 1 milligram per liter. Okay, so anything more than that, if people will get exposed to more than 1 milligram of fluoride in water, then they will get affected by a lot of diseases, right? And these diseases are known as fluorosis. And if there will be mottling of teeth, the teeth will get damaged, and it is known as dental fluorosis. And as fluorine is completely electronegative in nature, our bones are calcium that are electropositive, so they will be attracted to our bones and they will get deposited in our joints, and it will make our bones cripple, right? And that causes a crippling of bones, which is known as the skeletal fluorosis, right? So here is my study area. In this map of India, we have state Odisha, and this Odisha, this is the Niagara district. And in this Niagara district, there are 3 blocks. One is the Begunia block, Bhapur block, and Bologat block. In these 3 areas are the main hotspots of this fluoride. And going to the methodology and result, all the samples from the ponds and the wells were collected, and the waters were collected from near the hot spring also and away from the hot spring. The hot spring present there is known as the Tarabala hot spring, and the water samples collected, they were tested, the pH, EC, and the total dissolved solids. They were measured using the TDS meter on site, and after bringing it to lab, all the standard methods were done, given by the APHA 1995. The sodium and potassium ions, they were analyzed by the flame photometer, and the sulfates and nitrates by a spectrophotometer, and calcium was analyzed using the EDTA titrometry, right? And the fluoride ion, which is the main study ion, it has been analyzed using the SPANS method, okay, and spectrophotometer. So what we observed here is that the water samples that were collected from near the hot spring area, they contain more fluorine as compared to the other area. Around 14 milligram per liter of fluorine was found in the water bodies that were present near the hot spring, while the maximum a maximum of 10 milligram per liter of fluorine was found in the adjacent areas. Okay, and it was also observed that the water near the geothermal waters, they have a surface temperature of about 50 degrees Celsius, and they have a slightly alkaline pH around 7 to 9. So these samples were observed to have a high sodium content but low calcium and potassium content, the geothermal waters. So we have concluded that according to the N. Kundu et al. In 2001, They have studied that the source of fluorine may be granitic gneisses, which is the main lithology of the area, and this granitic gneisses, they are supposed to contain a lot of fluorine minerals like apatite, fluorite, and zeolite in them, which in turn solubles in get themselves soluble in water. And this anomalous high amount of fluoride in the geothermal water may be because of the high solubility of fluoride in the alkaline rich water. Here we can conclude that the waters which are more alkaline and which have a higher temperature than the room temperature, then the fluoride will get easily dissolved in that water. Right, and this clearly demonstrates how the geochemical effect of hot spring at the present area can affect the geochemistry of that groundwater. So I want to thank God for giving me strength to complete this work, and I also thank my guide, my seniors, and my colleagues and my parents too, who always extended a guidance and a hand of support. Thank you.
Thank you so much, Emmanuel, for your wonderful presentation. And also, most importantly, you completed your presentation in the given time frame. Next, I would like to ask the judges to ask him any question. Sir, if you want to ask him any question, or shall we proceed?
No, it can proceed. Next participant.
Thank you, sir.
Okay,
We
sir.
have up to time. Yeah.
Thank you, sir. Next, we have with us Sumant Kumar Pandey, BBMQ Dhanbad. Sumant, start your presentation.
Am I audible?
Yes, you are audible.
Am I audible or not? Yes, thank you. Very good
Yes, you are
afternoon to
audible.
everyone. Myself, Sumant Kumar Pandey. I am a student of PKR Memorial College, Dhanbad. Let me share my screen. Wait. My screen is visible. Hello. My screen is visible or not? Please reply.
Yes. Well, start your presentation.
Okay, just give me 2 seconds. Just give me 2 seconds. Just give me 2 seconds. It's loading. So yes, now it is visible, I think. Okay. My topic of presentation is phytomining and phytoremediation. That is using of biotechnologies in mineral extraction and metal recovery. So this is my brief abstract of my presentation, that the earth supply of metal ores is limited, as we all know about that. But due to unique physical and chemical properties of metals, its demand is getting high day by day. So we need some methods that we can extract metals from even metallic waste or mineral processing waste, or from, so we so actually अभिषेक थोड़ा side hit अभिषेक एक second. So sorry, actually, so the earth supply of metal ore is limited, so we have to, but due to unique property of physical and chemical properties of metal, demand of metal is getting day by day high. All we know about that. In future, when supplies of high grade ore will be ran out, so we will have to get that metal so that we can make necessary electronic goods and other goods. So we have to search for some novel techniques for metal recovery and cleaning metallic magnet mining site through certain plant species. What are those plant species? So first is Bacchole codil, that is found in South Africa. Alcyum bartodini, that is found in Italy. Pylanthus species, that is found in Malaysia. And one more is Brassica juncea, that is found in India and some part of Asia. So what is basically biomining? So biomining, it consists of two things. First is of mining through microbes, and second is mining through plants. Now it is the second part of my presentation. So what is phytomining? Phytomining is basically extraction of earth's low grade metal or even high grade too using certain plant species. And what type of metals we extract from that, like for example copper, nickel, gold, iron, titanium, cobalt, mercury, etc. And secondly, what is phytoremediation? Phytoremediation is a process of cleaning of mining site that is polluted with heavy metals like nickel, cobalt, iron, fluorine. So actually in India, fluorosis is a major issue, and present of iron in water is also a major issue that causes many genetic disorder and problem. So what is the methodology of my presentation? So certain plants are naturally hyper accumulated that they can extract metals, nickel like cobalt, manganese, copper from earth through their root. Actually they have natural property of that, and they convert them into biochemical fluid or hormones and store them into sap. That can be shown in the figure, so one can see it in the figure. So when later the sap can be extracted through metals by burning or it or any chemical refining process. So that is the process by which we can extract metal through phytomining. So similarly, such plant species can be used for phytoremediation. Similarly, we can use this type of plants in phytoremediation, that is cleaning of mining site polluted with heavy metal. So in the figure you can see these are hyperaccumulator plant. So let me say that it is a Pylanthus species that is typically found in Borneo Island of Malaysia. So when these contain iron, nickel, and copper like metals in their earth crust, it will absorb their all metals from their root and convert them into hormones and store in their sap. So it will also, so you can see that the agricultural land is not metal polluted now, so one can farm on that soil, and even the water is not what completely safe with this process. So it is a process of completely phyto remediation is a completely making safe for a future of and extracting metals. So what is the conclusion? So actually coming to the statics, we have certain species of Brassica juncea that is found in southern part of India. So it can extract gold and copper. And similarly we have Berkeley Codley, which can extract nickel from hyperaccumulator root. That 1 hectare of Berkeley Codley can farm actually 20 tons of nickel. That is a very big amount. Similarly, for and the first phytomining was done in California, USA, where 100 kg per hectare of sulfur free nickel was extracted. Now this is also done in some part of France and other part of world. And India is also doing in some part, like in southern part of India, it is done with the help of Brassica juncea, which can be shown in the figure. So what are the benefits of using this? That you can clean the agricultural site as some lands become infertile, where we know that as metals contaminated pollute makes the lands poisonous and underground metals. So underground deposits of metal present in low amounts such as fluorosis, nickel can cause various diseases and then genetic disorder. So that can be extracted from this procedure. So we will be safe in the later procedure, that no rural areas, no people will be find or genetic disorder due to such things. So let me, in spite of this, day by day global demand of metal is increasing, so we cannot neglect value of low grade ore. So actually basically phytomining and phytoremediation is done for two things: firstly to extract matter from low grade ores, and secondly to clean the sites, mining sites that are mineral processing waste, to extract metal through this. Not like not eco-friendly traditional techniques which use like smelting, which we currently studied in metallurgical process that uses high amount of energies and burning. So what is are the prospects? So these hyperaccumulators are grown on high or low mineralized soil or post mine lands of their yields bio, or as this can actually this phytomining plants, that hyper accumulators can be grown in any metal or metal that contains high level of mineralized soil of nickel, copper, aluminium, zinc, so which that can be extracted through this. It also can be, it extra can be clean the site, so which are polluted through mine waste which contains minerals of such valuable that are not valuable. For example, pyroarsenite, which which contains low amount of silver, but we left that because we cannot be extracted through. So but we can extract that silver from this method. So there is a process, this phytoremediation. So this is a picture of Indian coal mines for gold extraction. So this is the picture, mineral processing waste. So where India is getting this on thing. So now this is, I think this is over. This is the whole concept of phytomining and phytoremediation. It is a completely basically on biotechnological use for metal mineral extraction and metal recovery. So thank you. So if anyone to ask any question regarding this, so you can ask me. Yes, I am audible or not?
No, we
Yes,
are
you are
moving
audible.
out. We are moving out of
Yes,
time.
sir.
I think next participant.
Yes. Actually, my presentation is finished.
Yeah.
You can ask. Okay. Thank you. Okay, thank you.
Next.
We proceed to our next contestant, Vijay Kumar Nayak, Vyasnagar Autonomous College. Please start your presentation.
Yes, Vijay Kumar Naik, you can share with your slide. Share your slide, please.
Sir, I guess I have enrolled in the quiz competition, not in poster presentation.
Okay, thank you. Next we have with us Adarsh Kumar Pandey. Here you have it. Start sharing your presentation. Others, are you there? Please respond.
Yes, sir, I am there.
Yes, please start your presentation.
Yeah, just start.
Yes, sir, I am here. I am audible.
Start sharing your slide.
Sir has not given me the permission to share on my screen. Start करो. I am audible.
Yes, carry on.
You can proceed. We are moving out of time. You can proceed.
I am Adarsh Pandey from BBMQ University, PK College, Dhanbad. Today I want to deliver a topic on the poster presentation, earthquake as a natural disaster. Earthquake as a natural disaster and a preventing measure. In today's time, earthquake is a major devastating phenomena. The seismic waves which originated in the tallest building may mainly broken the stability of the buildings in the foundation. Today, major phenomena is that to how to conquer the earthquake. Today, earthquake originated from the area by area, like Japan in Tokyo, like Bhuj in Gujarat. These are the earthquake prone areas. These areas are very much cause the devastating earthquake. So we have to prepare ourselves for the earthquake. First, we have to secure your space. In today's time, the building is constructed so much that The building is so much constructed that the people who are constructing the building are not knowing the norms of the buildings and the soil type. Without any without any scientific procedure, the buildings are built. Due to this, the earthquake came and the building will collapse. This can cause the whole damage to the life and property, and many people lost their lives. So I want to adopt a measure. So earthquake. First, be prepared for the earthquake. If the earthquake is happening, first goes out of home or in a nearby field, because if we go to a nearby field, the building will always collapse and the people will not be die. Protect yourself. After the earthquake, the we have to listen the radio frequencies. In today's time, the pole bearings like lead bearings are used in the foundation of the tallest building. In 2015 2014, the National Geologist Framework has been adopted a new policy that the lead bearings should be used in the earthquake prevention. A lead bearings is a lead core which is situated inside under the foundation of the building. When the building is when the building foundation will become when the building should be constructed before the foundation, it is placed between the two steel plates one by one. This steel plate can reroute the seismic waves originated from the earthquake. This can very much helpful for the civil engineers to tackle over the earthquake. And second method is anti-clocking measure. Anti-clocking measure is also a good also a very good good process used by the civil engineers to tackle the earthquake. Earthquake means the base isolation system is also currently very much used in the countries. The base isolation is like the base isolation is like the base isolation is like in the base isolation is one of the most widely accepted seismic protective system in earthquake prone areas. It mitigates the effect of an earthquake by essentially isolating the structure from potentially dangerous ground motion. Seismic isolation is a design strategy which uncouples the structures of damaging effect of the ground motion.
Others, you exceeded time limit. Please finish your presentation fast.
Yes, I am presenting. So, the seismic waves caused by the earthquake weaken the stability of building, especially taller buildings. The collapse would be cause significant damage. One inexpensive method of advancing seismic control is base simulation. Fixed base structure versus isolated base structure. Now, if the same building is rested on the flexible part that after resistance once again lateral movement, then some effects of the ground shaking will be transferred to the building above. The flexible pads are called basial isolators, where the structure protected by means of these devices are isolated building. The main feature of this base isolation technology is that it is flexible in structure. Japan, many of the countries use the home to make with the wood, because if the wood is the house which is constructed lost, and if the house constructed with cement and bricks, the lives would be property. If there is very much earthquake prone areas, I will prefer that the buildings will be constructed with wood, because it can withstand the earthquake wave, and no much more tall buildings will be constructed on the areas without proper guidance. And the governments and private firms should make a strict laws enforcing that no one should construct the building without any proper experiment done by the engineers. Thank you.
Thank you so much, others. And with that, this session is over. I hope you all enjoyed it. Thank you so much. Now I hand over to Ananya for proceeding the event. Thank you.
अरे मेरा नाम नहीं है.
Your name is not in the list. Okay, if you want,
You
you
have
can
sent in the
present.
WhatsApp.
Yes, please share your screen and your presentation within next 5 minutes if you want.
Allow me. There is. अरे ऑप्शन नहीं दे रहा शेयर करने का.
Hello guys.
हाँ भैया.
No, I'm not talking. I'm talking to the coordinators actually.
Yes, sir. Yes,
Uh, I was asking that are we going to start the quiz competition or not?
Yes, we are going to start the quiz competition.
Okay.
Okay.
Okay, moving forward. Good afternoon, everyone present here on another day of this workshop. I am Nidhi Anza, and I welcome you all for this quiz session. That is the game of mind, intellectual interest, power, and joy. But before entering into this wonderful quiz, let me introduce. Sorry. So moving ahead. At first, we will call two participants for face-off, and each one of the participants will answer 10 questions. Okay, we are moving forward. So I will call.
Yes, we will now start the first round of the quiz. Swati and Gaurav, are you there?
Yes, sir. We are here.
Okay, the first round, the first question. Can you see it on the screen?
Yeah.
Yes, sir.
Yes, the first one to answer will get 1 point.
Okay, so the first question has the B option, sedimentary rocks.
Okay. Question option number 2. Question
Yeah.
number 2. Rift valley is formed due to Swati and
B
Gaurav.
option.
Please repeat that.
D option. D option. D option actually.
Swati.
Hello, sir.
Yes. What's
Sir,
your
D
answer?
option. D option.
Okay. Yes, the correct option is B. Okay. Question number 3. Question number 3. You can see it on the screen. What is the right answer?
B.
Okay, B is the correct answer. Gaurav. And number 4, question number 4, you can see it on the screen. Which one is the correct answer?
A.
C, sir. 17.
No, the correct answer is actually B. So both of you are incorrect. The correct answer is actually B. Question number 5. Which
Sir,
one is the
B.
correct?
B.
B.
Okay, you both answered at the same time, so you will both get 1 point each. Now question number 6.
Sir, A.
C. Yes, Swati is correct.
Yeah.
Question number 7.
Sir, C.
Gaurav, what did you answer?
B.
And Swati, what is your answer?
C.
No, the correct answer is actually B. Okay,
I
moving on
said
to
B.
the next question. Oh, Gaurav, did you answer B? Okay.
Yeah.
Moving on to the question number 8. Please pick the correct statement from the following.
D.
D.
Yes, Gaurav is correct. Moving on to question number 9.
C.
Yes, Gaurav is correct. And question number 10. Question number 10. Question number 10. Explanation is common in. Yes, what did you answer?
B. Results.
Yeah, the correct answer is B, which Gaurav answered. Okay.
Okay. So how much points I
Okay,
have?
that concludes the first round. Gaurav wins this round by 7 points. Swati has 3 points. 2 questions were not answered correctly. And that concludes the first round. We will move on to the second round shortly. And after 5 rounds, the one with the most number of points will be the winner. Okay, we will move on to the next round for Tripurari Kumar and Karthik. Are you?
Yes, sir. Yes, sir.
Karthik and?
Yes, sir. Yes, sir. I am present.
And Tripurari Kumar?
I am here.
Okay, we will now move on to round 2. Question number 1. Yes, which one is
Sir,
the
C,
right answer?
C option.
And who are you? What's your name?
Karthik.
Okay, you are Karthik. Yes, C is the correct answer. We're moving on to the second question.
Excuse me, sir. 1 minute. Just I want to.
I told C, sir.
Huh? Which one? Which of you answered C?
Sir, I am Karthik.
Karthik, you answered C.
Yes, sir. Yes, sir.
Yes.
I answered.
Tripurari, your voice is not coming through clearly.
Sir, I too answered C.
Okay, but Karthik answered before you. Therefore, he is the one who gets the point. And the one who answers first will get 1 point. The next question. Yes, the question number 2. Which
Sir
is the
B.
correct answer?
Sir B.
Okay, is this Karthik?
Yes, sir. Karthik.
Okay, B. Tripurari, the correct answer is B. Karthik gets 1 point. Question number 3.
Sir B.
Which is the correct?
B. Climate Atlas map.
Sir B.
Okay, Karthik. No, the correct answer is actually, which one is your answer, Tripurari?
B.
No, the correct answer is actually C. So this round, this question, no one gets 1 point. Question number 4.
Sir B.
Okay. The correct answer is B. Karthik gets 1 point. And question number 5. Conchoidal fracture is?
Sir.
C, sir. C, sir.
Is this Karthik?
Yes, sir. Karthik. I answered
Tripurari,
C.
your voice is not coming through, Tripurari, clearly. Please check your connection. The correct answer is actually C. So Karthik gets 1 point. Question number 6. What's the correct answer?
Sir D.
Tripurari, what's your answer?
B. Option B.
No, the correct answer is actually C. Okay, moving on to the next question. Question number 7. Question number 7 is, a land is known as waterlogged. Which one is the correct answer? I'm repeating the question.
C.
A land is known as... Okay. Okay, Karthik, C is the correct answer. Moving on to question number 8. The earliest fossil of foraminifera are found in... I'm repeating the question. The earliest fossils of foraminifera are found...
D, sir.
C. D.
Sir, my answer is
D
B,
is the
sir. B,
correct
sir.
answer. Yes. B, okay. No, Karthik answered correctly. D is the correct answer.
Okay, sir.
Okay, moving on to the next question. The rocks of the Paleozoic era are known as. Sir, 9. Question number 9. Sir. The rocks of the Paleozoic era are known as shale, graphite, granite, limestones. I'm repeating the question.
Sir D.
The rock.
Sir D.
D. Okay, and what's other participant of answer? Tripurari, what's your answer?
B.
B.
Sir, option C. Granite.
No, both of you are incorrect. The correct option is actually A, shale.
Okay.
Moving on to question. The phenomenon of river capture is associated with. The phenomenon of river capture
Sir
is
A.
associated.
Sir A.
Is this Tripurari?
Karthik, sir.
Karthik. Yes, Karthik, you are correct. Question number A is the correct answer. Okay. The winner of this round is Karthik with 7 points. Okay. Now we'll request participant 5 and 6 to unmute yourself. Participant 5 and 6.
Yes. Emmanuel here.
Yes. Question number round number 3 is Sinjan Roy and Emmanuel.
Yes,
Are
sir.
you there, Sinjan? Emmanuel?
Yes, sir. Yes, sir. Emmanuel here.
Okay, Emmanuel and Sinjan. Okay, we will now begin round 3. Are you ready?
Yes.
Yes, sir.
Before you answer, please, after you answer, please say your name so that I don't confuse between the two of you. Question number 1, please read your name.
River erosion is responsible for the formation of
Games. Emmanuel. See,
Okay.
potholes. See potholes.
Yes, and Emmanuel, you are chemist. You said chemist and then you said pothole. Which one is the correct?
Yes. See potholes.
Okay, Emmanuel, you are correct. C is the correct option. Moving on to question number 2.
the columnar structures bounded by long cylindrical surfaces are called
Mullian. Budinage. Rodding.
Sir, C.
Okay,
Emmanuel.
Sinjan, what's your answer?
C.
Okay, and Emmanuel?
I will say
I
A.
think Emmanuel,
Budinage.
Sinjan answered C and Emmanuel answered Budinaj A. The correct answer is actually C. So Sinjan is correct. Okay, moving on to the question number 3.
which of them is used in extraction of metals?
B.
B.
Okay.
B, sir.
Okay, Sinjan, you answered first B.
Yes, sir.
So B is the correct answer. Moving on to question number 4.
According to Bowen's reaction series, which of the following pairs of phases are likely to be incompatible?
So C.
What's an alkali?
So C.
Okay. C. Who said C?
Sir, me, Sinjan.
Okay, Sinjan, you are correct. C is the correct answer. Moving on to question number 5.
Asterism is caused by
D.
Sir,
D.
B.
D.
No, none of you are correct. The correct answer is actually C, none of the above. Okay, there has been problem. Okay, the correct answer is actually none of the above. Is C. And so this round, no one got any points. Question number 6.
Aventurescence is a phenomenon caused by
So B.
Who answered B?
Sinjan.
And what's your answer, Emmanuel?
A.
Okay, Emmanuel, you are correct. A is the correct answer. Moving on to question number 7.
if the dew point is greater than 0 degrees Celsius.
C.
Okay, Sinjan. Question number
C.
7. And Sinjan, what's your answer?
Sir, it should be A.
Are you sure?
Yes, sir. Yes, sir. Just taking this one. I can't.
Okay, Sinjan, you are correct. Correct answer is actually A. Question number 8.
Which was the first horse in Old World?
Equipus. Equipus. C. C.
Is that Emmanuel?
Yes.
Emmanuel, what's your answer?
C.
And Sinjan, what's your answer?
B.
Okay, the correct answer is actually C, Eohippus. So Emmanuel, you get 1 point here. Moving on to the next question number 9.
Underground water's action is responsible for the creation of
Sedimentation. Giant
C.
staircase. Carbon giant staircase. No, cementation. Cementation.
C,
C.
sir, C. I said C.
C. Cementation.
Is that Sinjan?
Yes, sir. I
Emmanuel.
said C.
Cementation.
Please repeat, Sinjan, what's your answer?
C.
And Emmanuel, what's your answer?
Right on C, sir.
Sinjan, you answered C. You are correct. You answered first. You are correct. C, cementation is the correct answer. Question number 10.
Which was the last of Old Stone Age man?
Neanderthal. D.
And Sinjan, what's your answer?
So I think it's A.
Yes, Sinjan, you are correct. Cro-Magnon man is the correct answer. In this round, Sinjan wins by 6 points. Thank you for both of you for participating. We will be moving on to the next round. Priyajit and Vijay, are you there?
Yes, sir. Yes. It is here.
Priyajit, please say hello.
Hello.
Okay, Vijay, please say hello.
Hello. Hello.
Okay.
Priyajit here.
Okay, Vijay, are you there?
Yes, sir.
Okay, we will now be asking the first question of the fourth round.
Earth has an average surface temperature of
Sir, C. 15 degrees Celsius. Vijay. D.
Priyajit?
D.
Okay, the correct answer is actually C. So Vijay is correct. The correct answer is C. 15 degrees Celsius is the average surface temperature of Earth. Moving on to question number 2.
stone lattice is formed due to
Sir, B. A. Priyajit is A.
Okay, Priyajit, you answered correctly. A is the correct option. Moving on to the third question.
choose the correct statement regarding current ripple marks.
Sir, D. Sir, D.
Vijay, what's your answer?
D. D, that is.
Priyajit?
Priyajit, B.
Okay, Priyajit, you answered D. Vijay, what's your answer?
Sir, my answer also D. No, mine is B. Second one.
Okay, Vijay, you answered first. D is the correct option. So you get 1 point. Moving on to question number 4.
PCRA stands for
A. Priyajit A.
Okay, Priyajit, Vijay, what's your answer?
D.
Vijay, you are correct. D is the correct answer. Question number 6. 5. Question number 5. What's
describe the plate tectonic settings where you would expect to find granitic rhyolitic rocks.
B. Sir, B.
Okay. Priyajit said D. Vijay said B.
Then second one, B.
Priyajit, what's the answer?
Continent collision.
Okay, Priyajit. Vijay, what's the answer?
The same. Continent collision.
Okay, Priyajit, you answered first, so you get 1 point. It's B. Moving on to question number 6.
Most common gem minerals are members of the
Sir, A. Sir, metric system. Sir, A.
Okay, Vijay, is that Vijay?
Sir, yes, sir, A. My answer is A. Vijay.
Okay, Vijay, you answered first. A is the correct answer. So moving on to question number 7.
as compared to gravity dams, earthen dams.
A.
Okay, Priyajit, you answered A. Vijay, what's your answer?
B.
B.
Yes, sir.
No, the correct answer is actually D. The correct answer is actually D. So none of you are correct. The correct answer requires less skilled labor. And question number 8.
The brain capacity of modern man is
Sir, A, 1500 cubic centimeter. A. Sir, A.
Okay, Priyajit, you answered first. A is the
Sir,
correct answer.
first.
Yes, what?
Sir, I guess I answered first 1500.
Oh, is that you, Bijay?
Yes, sir.
Okay, there has been a mistake. Bijay answered first. So, yes, Bijay gets 1 point in this question. And question number 9, moving on to question number 9.
Docky fault is a
Docky fault is a
Sir, D. B.
Okay, Bijay, you answered
Low angle
first.
thrust. Sir,
Bijay,
I answered D.
You answered?
D. Carabin and host.
Okay, Priyajit, what's your answer?
Low angle thrust.
Okay, Priyajit, you are correct. The correct answer is B, low angle thrust. Question number 10.
repetition of beds on a geological map may be due to
Sir, C. Unconformity.
Okay, Priyajit. Okay, Priyajit, you are correct. A is the correct answer. In this round, Vijay gets 5 points and Priyajit gets 4 points. So Vijay wins this round by 1 point. Thank you both for participating. We will now be moving to the final round. Surya Narayan and Mohammad Almas Riyaz.
Yes, sir. I'm present here. Yes, sir.
Almas,
Mohammed.
Almas, your voice is
Hello.
repeating.
Hello. Yes, sir. I'm speaking.
Almas, your connection is not working properly. Your voice is getting repeated.
Hello. Can you hear me?
Is that Surya?
Yeah.
Okay, Almas, are you there?
Yes, sir.
Okay, we will now be moving to this last round. First question is
chasms are found in
Sir, C.
Okay, Surya, is that Surya? Almas,
C.
you answered.
The C. Rock with the horizontal shadow. Sir, I answer C.
Okay, Surya, you answered.
C, sir. Rock with horizontal shadow.
Almas, what's your answer?
Sir, C. Rock with horizontal strata.
Okay, both of you answered C, but the answer is actually D, rocks with vertical strata. So none of you get 1 point here. Moving on to question number 2.
mud cracks
B. D, sir. D. Sir, D. Sir, D. I say first, D.
No, none of you are correct. The correct answer is actually A. In normal position are wide at top and taper downwards. Question number C.
the layer containing petroleum oil and gas is
Sir, A. Above the
Okay.
water.
Okay, Almas answered A first, so he gets 1 point here. Next question.
describe the plate tectonic settings where you would expect to find andesites.
The C. Splitting center. B, sir. Continental.
No, the correct answer is actually A. Okay, question number 5. Question number 5.
The hexagonal crystal system differs from all others in being composed of a unit cell that
Sir, D.
Surya, what's your answer?
Yes,
Almas?
sir.
No, sir. C, sir. Sorry, sir. My answer is C.
Hello.
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 Yes, due to some technical issues, we underwent some problems. Can you both hear me?
Yeah,
Yes, sir.
yeah. I hear you.
Okay. The next question is question number 5. What's the correct
Sir,
answer?
D.
Okay,
Yes, sir. D has 6 phases.
Surya, what's the answer?
My answer is A. Has 4 imaginary axes.
Okay, question number Surya answered A and Almas answered.
D.
Okay, the correct answer is actually A. So Surya wins this question with 1 point. The next question, question number 6. Pick up the correct statement from the following.
The please call your same.
Please repeat your
Hello.
answer.
It is not
Yes,
visible.
please. Yes.
Hello.
Is it visible?
No, no.
Question is not visible.
Your voice is not clear, sir.
Okay, hold on 1 minute. We are switching to another device. Hello, can you hear me? Hello, can you hear me now?
Yes, sir. Yes, sir.
Okay, question number 6. Pick up the correct
Pick up the
statement from
correct
the following.
statement from the following.
Sir, screen is not showing.
Screen is not showing. Okay, I'm going to say the answer options.
Sir,
Ice
D.
cream is visible,
D.
sir.
All of the above,
Sir,
sir.
D.
6. All of the.
Sir, I said first.
I
D.
first. I all of. All of the above. I said first.
Okay, the correct answer is actually all of the above. So, Almas wins this round.
Hello. Hello,
Yes,
sir.
hello, can you hear me?
Yes, sir.
Okay, we are moving on to question number 7. See the screen?
This case is
No,
not
sir.
visible.
Okay, I will read out the question. Okay.
Okay.
Okay, the question number 7.
Okay.
The fossil of Archaeopteryx were discovered from option A, Triassic rocks, Assam. Option B, Jurassic rocks of Bavaria. Option C, Cretaceous rocks of Texas. Option D, Permian rocks.
Sir, C. C. C.
I said first. C.
Okay, question number 7. The correct answer is actually B, so none of you are correct.
Okay.
Okay, moving on to question number 8.
Caps, caps.
Sir, A.
Sir, caps. B.
Sir, A.
Sir, your class, your
Sir, A.
Okay,
sir, your voice is not
Almas,
clear. Please.
can you hear me now?
Yes, sir.
Yeah,
Yes,
yeah,
sir.
here.
Okay, Almas, you answered B.
A. Horns.
Okay, Almas, you answered A. And Surya, what's your answer?
So my answer is B. Caps.
Okay, Surya, you are correct. The correct answer is actually B. Okay, question number 9.
Sir, A. Mica. Mica. A.
I said it
Sir,
first.
A. Mica. Sir, I said first.
Correct answer
You
is
know.
actually Mountain.
A, sir. My cap.
A. Mica, sir. I said first.
No, the
The
correct answer
tourmaline.
is Mountain is the correct answer.
Hello, sir.
Yes.
The tourmaline is the answer.
No, tourmaline is wrong. The correct answer is
Sir,
actually
Sir, Sir, D.
sorry,
No, no.
I gave the answer.
You say my cap. Then you say tourmaline. Then you say hornblende. क्या है?
Mountain is the correct answer. I never said tourmaline. Okay, moving on to
No.
question number 3.
Sir, your voice is not clear, sir. The seal. But
A. Sir,
seal.
A. Dike.
I said seed B. B is the correct answer.
Okay, B is the correct answer. Surya,
Surya said.
you answered B.
C. Yes, sir. B, sir. Seal. Seal
Okay,
is the
Surya.
correct answer.
Yes,
Get to
Surya,
see
you are
that.
correct. B is the correct answer.
Yes,
Seal
sir.
is the correct answer. Say B.
Yeah.
Okay. In this round, Surya wins this round by 3 points. Thank you for participating. Okay, now we
Can you
will.
say it clearly that who won this round? Because your voice is not clear.
मेरा वॉइस नहीं जा रहा वहां से Is my voice audible? Hello, is my voice audible? Hello,
Hello.
is my voice audible?
There is an echo in your voice. We cannot hear it properly. It's like a concert is going on.
Okay, wait a minute. Hello, is my
Don't you
voice?
have a mic? Yeah, voice is clear, but actually echo is there. So yeah, you can speak that who won that round, the final round, fifth one.
Okay, the final round final round is won by Surya by 3 points. We will now
Right?
check all the marks of all the participants in the 5 rounds and decide on the first, second, and third winners.
Okay. So who is the winner?
हाँ सर ऑर्डर हो गई
वो अभी पसंद आ गए वो पूछना। नहीं वो आ गया है, वो अभी मेरे को फोन किया तो रास्ता में है, तो अभी पसंद आ गया। हाँ हाँ वो प्रिंसिपल सर का है। अच्छा। तो अभी जो है स्क्रीन शेयरिंग, हाँ
Hello, is my voice audible?
Yeah,
Hello.
yeah, your voice. Yes.
Okay, so after assessing all of the marks, the first block marks is obtained by Gaurav and Karthik is a tie by 7 points. So we will decide on the winner by the one who got 2 marks in round 1. So in round 1, Gaurav received 43 out of 60 and Karthik received 49. Therefore, Karthik wins the second round by tiebreaker. And the second winner is Gaurav. Third winner is Vijay. Congratulations to all three of you. Is my voice clear?
Yeah, yes.
Yes, sir.
Sir, please once again, I can't hear.
Yes. Can you hear my voice now? Hello? Can you still not hear me?
Yes, sir, I got it.
Okay, Karthik wins this round by 7 points. Gaurav also received 7 points, but he received less marks in round 1, therefore he is second in this round. Third winner is Vijay by 5 points. Congratulations to Karthik for winning round 2 of the quiz and the overall quiz competition of this workshop. Thank you both for participating. We will be doing award ceremony later on. So you will all be contacted later with further instructions on prizes and certificates. Thank you for joining us. Hello, which session is over now. Now we move towards our next session, that is panel discussion. Okay.
Now it's time for panel discussion. Special ladies and
Hello, am I audible? Hello, am I audible?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you.
to our next session, that is panel discussion.
Our special guest is Mehul Sinha, Professor P.K. Jain, other participants, David Dept, Professor P.N. Shaw, and Dr. Daniel Pratap Singh are present here to participate in this on the topic of career and job in geology. One of the important topics for geology students.
Basically, we have selected this topic because every geology student wants to answer what is the career perspective and jobs in the view of industry or in academia. So, what are the opportunities for a student in geology? So, we have 2 points in which we want views of our eminent guest, member presenting the panel discussion. So, our first point is.
Our first point of discussion is career opportunity in the field of geology.
So I will request PNS sir, PNS Roy sir from IIT Kharagpur, please give your view on this point. What is the career in the field of geology? What is the career opportunity in the field of geology? PNS Roy sir.
Yes, thank you. Your voice was not clear. Can you repeat what I have to say?
So you have the topic of discussion is career and job perspective in geology.
Okay. Regarding this. Okay. A very good afternoon to the principal, Professor Sinha. Good afternoon to the HOD, Professor Swain, and present panel, Professor Jain, Professor Ganadhar, Professor Pratap Singh, and many more I can see, and also who are present physically there. So I'm very happy that a place like in Dhanbad, where I spent one of my best part of my life, 11 years. So it's full of resources, and honestly speaking, you have lot of not only finding resource or exploiting, but also you have the problem of man directly related to the humans. So I must say that the topic and the objective of this conference was fully benefited by the speakers. Especially I could hear some of the international speaker. One of them was the professor uh, from the UK. He has given so good information that you have good scope in Australia. So it's a really good thing, but you know that they will take after you have a experience. So you should have basically the first hand which you are getting the training here by one of your head and the teacher, Dr. Sagar Swain. He's groomed in a well setup of Indian School of Mines. I have seen him from the time of MTech, PhD, postdoc. He was associated with me directly with postdoc. He has published in reputed journals, so he's a good person to lead you. So your first-hand experience, and that too in a place where you have many geological problems to be solved. So in my view, that if you get in small companies, you should start. You should not hesitate. Your experience will count, and there are many opportunities you will come to know. And now this age is of, as you can understand, it is the age of the entrepreneurship. So I can share, when I was PhD scholar, one of my friend, he used to work in groundwater. So what he used to do, he used to go, we were in the BHU together. So in weekend, when I used to enjoy, he used to come down in Jharkhand and Ranchi, and he used to do electrical sounding to find groundwater. And he used to earn in weekend at that time when I was doing PhD in 2000s early. So he was earning 20,000 per weekend. So can you imagine at that time? So now, and he used to be very good in that. He used to use his geological concepts and his practical experience, and where whatever depth and where he used to say, they used to get the groundwater. And you know, in Jharkhand, where it is a hard rock area, it's not the alluvium plains where you have well-defined aquifer. So in that place, he used to do successfully. And now he is working in Central Groundwater Board. His name is Dr. Sashikant Singh. He is posted in Patna. So I would say that you people who are born to be an entrepreneur, you can make a group and start doing entrepreneurship, solving the mankind problems, especially groundwater is a big issue, and also a good quality groundwater. Also land use patterns and how to plan the city, smart city, many things. And nowadays microzonation is coming up in Dhanbad. So Ministry of Earth Science is taking understanding of the microseismicity and the microzonation ultimately. So I would give the all my best wishes to young generation who have chosen the topic, the subjects of geology, and that too in this leading college, PK Roy. I was telling you the first student of my PhD, which I guided in Dhanbad, Indian School of Mines. He was from this college, and he's now scientist in CSI lab, NGRI. So in a geophysics group. So I would say you are good students, and you should not hesitate in doing a small job or doing starting in any kind of just thinking that it's a small job. You should look at big companies, public sector companies. Time is changing now. It's a time of private, and your experience will really count. So I would end my whatever I had to say and leave it to the other panelists. So once again, thank you for giving this opportunity to share my view and my whatever I know from my experience and my friends. So wish you all the best and thank you. And that's all. Thank you.
Thank you very much, sir. So thank you,
Thank
sir.
you
You
very
have
much.
guided us very much from the beginning. You have supported us a lot, sir, for this workshop. So thank you very much, sir. Now we will move to Gabriel. So, sir, David, it's my humble request that you please unmute yourself and give your views on this topic, the career prospect opportunities in the geology, the career opportunities in the geology. So you are not audible, sir.
Please rejoin. Maybe you require to rejoin. Same problem I was having. So if you rejoin, it may work.
And now, can you hear me?
Yes, sir. Now
Yeah,
you are audible.
now it's fine.
Well, I fully agree with what Professor Parish was saying. It's really important to get experience early because companies value this highly, and I would like to extend to that from the perspective of a student that is still studying. You can already try internships in big companies, because it's easier to enter as an intern than as a student than as a job directly in a big company. So if you can already as a student get internships in prominent companies, this really helps later on in terms of opportunities, because it looks good on your CV and they already know you, so you're a known quantity, and they're more likely to select you and consider you later on when you apply for a real job, well, a job there, an actual job after you graduated. So yeah, that's what I would add. And I don't know the situation in India specifically. Yeah, I'm Belgium, and I'm currently in Brazil. So the situation is different, but geologists tend to be really mobile internationally, and because the internationally most people speak English, and everyone in India speaks in English. Well, you really have an advantage there. You can easily move between countries, move to Australia, where there's a shortage of geologists. Not to say that there aren't many opportunities in India, because India is an enormous country with many opportunities, many resources. And if you're already as a student, if you're developing skills, it's interesting to keep in mind how these are valued, which skills are valued by companies. Things like working with geographical information systems, geophysics are really valued, and the skills that you acquire in geophysics for exploration translate really well into the skills for ambiental applications. They, like Professor Parish mentioned, the prospection for groundwater, you can easily apply the same methods or similar methods for tracing contaminant plumes in groundwater. So geophysical methods are really versatile and useful. So these are the things that I would add.
Professor David has done so. So please continue, students. Your is muted. We are not able to hear anything. HOD Geology is shown muted.
Sorry for
I think
inconvenience,
they
sir.
have problems with the internet, because their image is also really blurry.
On this topic. Thank you very much, sir.
Now I would request Dr. Ganendra Pratap Singh to please share your views on the topic career opportunity in the field of geology.
So, sir, Gyanendra Pratap, sir.
Okay, thank you very much for giving me this opportunity. And I am extremely no, privileged to be a part of this international workshop. I would love to salute the Honorable Sinha sir on the dais and Dr. Sagar, who is the head of the department, Professor PNS Roy from IIT Kharagpur, Mr. David from Brazil. It's good to see you. And yesterday I could hear or listen to one honorable participant from Cape Town, South Africa. No, so you organize such a platform where we could interact and we could get to know with the latest developments. So one participant yesterday was mentioning that probably in Australia, where the number of students that are required to go for post graduation, they are not getting their seats fulfilled. But unlike Australia, the conditions situations in India are different. There are so many institutes where this no students are offering post graduation geology. So what is more important is that to maintain that quality, to have that knowledge that can directly be applied so that they can get a job. A job probability is not the problem, I think, in India. But the what is more significant is that whatever knowledge they gain over the period of time, they should be able to apply in the field because the subject is related directly to the field. And what the students study in the classrooms until their post graduation is different from what they see in the field. So uh, I feel myself, extremely privileged uh, that I could see virtually Professor PNS Roy, IIT Kharagpur, Mr. David from Brazil, and one person from Cape Town yesterday, and Amnen Sinha sir. I visited Dhanbad in year 2000 for a refresher course to attend there in ISM. So I used to know that Dhanbad means ISM and ISM means Dhanbad, and that was all that I knew about the Dhanbad and ISM. I enjoyed 1 month long stay there at Dhanbad. Presently, I am head of the department at Chhatarpur. It is a very small place known for Khajuraho, which is an international place close to Khajuraho. Right. So then I belong to Bhopal. Probably I'm waiting to go to my hometown on transfer. So this was a wonderful experience that you gave platform not only to very good lectures, speakers, but the postgraduate students they could present their papers as well. So this was a overall a nice opportunity to learn. And I thank you very much. Thank you very much.
Thank you, sir. Sir, we are also privileged. We are also getting wonderful decisions. Thank you, Gyanendra sir, for your view on this topic.
Now I would request Professor Sagar Kumar to please give his views on this topic, career opportunities in the field of geology.
Professor Pradeep Kumar Jain.
Please unmute yourself.
Sir, you are requested to unmute yourself and give the view on career and job opportunities in the geology. Pradeep sir.
I think he is not there. He is busy doing some other work. I know him because he is my colleague. So please you proceed further.
Okay, now we will request our guest Valedictory to give some view on this topic. Sir, please.
Thank you. And then there are students of you have already responsibility. And now, let me also thank Dr. Sina and Dr. Sagar for making this very program. Of course, I was not aware of this that the career, what is the career education in this field. But in geology, I always think of what are the scopes of doing something. First of all, I would say all the students here, first of all, you dream, you have a dream. Where you want to see yourself after 5 years. If you want to see do something, there is not much. But good for you. You can go for the banks or something. But that is very difficult. Is whatever you are doing here in this college. So definitely you have to go for the research. So first if you are not here for graduate, here you have to go for the stars. That way is not doing PhD or politics, but not doing PhD is story. So this is the thing. You see all you see the year of the senior year there. So and you can see mine also there.
We are not able to hear anything.
There seems to be a problem at the organizing end, sir. Uh, We are getting blurred pictures and
Yes, you're right. Internet is down.
Anyway, somebody wants to come? Whatever it is, then these are the and never disassociate yourself from the field. You have very good field in around what you are mining, you are already detailed. Please go to those areas and acquainted with the activities here. More you see, then more you understand. The way you do yourself, you never forget about it. So, as far as geology is concerned, after the like any other science or technology, but you give a choice. You want to go to be a professor, you have to be a teacher. And if you are dream, then you have to complete your career and go for higher studies, go abroad if you want. And for the situation is bad right now. But in order to be strong, you hope you are strong to believe that. The academy will not be easy. So don't give up. Radio is final, it's not final. Just remember, the day you stop trying, then you are failing. And whatever thing that you want to give up, you try to study like that, and you will really write steady. And always, last thing is that always respect your professors. Listen to them. They are nothing to get from this, but you are very respectful. Yeah. For them, it's a dedication that they are teaching. otherwise not get for some brighter reason. But some professors are the casual in the so listen to the professors, inspire you can also guide for them. But there are ample scope. You can be a professor, you can be a geologist, professor. You can be a geologist, a professor, a scientist, or a geologist, a professor, a scientist, or alternatively you can also be a bank officer, something. I want to say
Thank you, sir. Thank you for your view in this topic.
just career and both things will get success to any things in the life. When the continued MTech in ISM. Just I did not think where I'll go and what I have planned. Means I don't at that time. The most important part of our life. And in job perspective, I think it will not go to
Some audio problem here.
That was very few students. Yeah. Then what in geology also, if someone will take BSc bachelor in science, then I think MSc is the only option if we go for higher studies. MSc in MSc if they'll do in IIT or central universities or state universities, that is also so that will also means
After MSc also there is also
Actually, please keep HOD Geology muted and keep Ananya Sinha on.
Yeah, sorry for disturbing. After MSc, there is also the GSI also and ONGC. No, sir, in laptop also, I think. In MSc, after MSc also, there is option like GSI, Geological Society of, sorry, Geological Survey of India, then ONGC. For that also, if during MSc time also, if
I think there is some problem, technical problem at the organizer's end. Sagar sir, can you hear me? We are not getting you. The
Actually,
proceedings.
please keep HOD muted and keep Ananya Sinha on. Then it is working well, the audio. Please mute the
Yes,
HOD Geology.
after MSc, if we are not getting job, then also we can continue with MTech also. In MTech, in MTech also in several IITs and ISMs are there. That MTech is also a good option. There is no for learning everything it will do. That is good for us. After MTech, also one can get the job at the industry level, or also he can also go in GSI ONGC like that. And also we can go for also higher studies, PhD. If someone will not, if someone will not get job after MSc or MTech, also they can go for higher studies. Means what? Many career opportunities are there, but we'll have to do some hard work. First, we'll have to learn, then we'll have to explore, then we'll have to implement on it. These three things, I think, in daily basis, we'll have to learn some new things. Then we'll have to explore on it. Then we'll have to implement on it, so that some new ideas will come. And whatever this imagination will come, and this curiosity will come, then that will also grow our future. Then I cannot take much time as we are running out of time. So this is my point of view on career and job prospects. Thank you.
Thank you so much, sir. Thank you so much for the unnatural guidance. Now I would request Professor Jain to please give his views on career and job opportunities in the field of geology.
Yes, afternoon.
Let me add one thing
For
more.
everybody. The
Also very
career
important.
opportunities
In the
after
days of
graduation.
because 21st century is the day of renewals. So basically, often geologists are considered as the operators of the non-renewable resources. So in the days of renewals, what are the new opportunities coming to the geologist student? What we basically we don't aware of that. Hello, sir. You can proceed.
Afternoon, everybody. After getting their graduation, they can apply for the post of mining inspectors and mining surveyors. For in other Madhya Pradesh, in states of MP, there is a public service commission through they get post in MP PSC as a mining inspector, and after getting MSc, they can apply for this mining officers, Geological Survey of India, And for this Indian Forest Services, there is separate subject. They are taking a geology and other competitive examination, particularly ONGC, AMD, MECL, Hindustan Zinc Limited, Hindustan Copper Limited. There are so many fields for the postgraduates of geology. They can apply for the post of assistant geologist after passing their MSc, MSc Tech in geology. And this type of job serve in government sector and private sector. There are so many multinational companies, and they are offering job for MSc students or MTech students as a geologist. They can apply for the post. I am very much thankful to the organizing committee. They're giving me the opportunity to deliver my keynote talk, and this opportunity for this valuable speaks on this career in geology subject. Okay, thank you.
So please unmute yourself.
I am audible. Yes, I am audible.
Yes, sir, you are audible.
Okay. Good afternoon, everyone. I am thankful to organizing committee for organizing such international 2 days international workshop, particularly on this recent innovations and advances in geological sciences. Opportunity in geology: after passing graduation, the students can apply for Public Service Commission, particularly for students of offering the post of mining inspector after passing their graduation through Public Service Commission of every states. And after getting their MSc in geology or earth sciences, they can apply for the post of assistant geologist in Geological Survey of India examination, Oil and Natural Gas Commission, Oil India, Hindustan Petroleum. These are the job prospect for the petroleum industry, as well as in the other Reliance industry, Reliance Gas Limited. And particularly for this, after passing the MSc and MTech from Earth Sciences and Applied Geology, they can also apply for the post of geologist in the Hindustan Zinc Limited, Hindustan Copper Limited, Mineral Exploration Corporation Limited, and so many others, just BARC, Bhava Atomic Research Center, and Atomic Minerals Division. These are the posts as they can apply as assistant geologist or scientist in different government organizations. Particularly, they can also apply for the private sector, multinational companies offering the jobs of geologist in private sector also. So there is at present, there is a good opportunity to get job in earth sciences students for this geology field. I am very much thankful to organizing committee. They are giving me opportunity to delivering the keynote talk, and they invite me in this valedictory function. Thank you very much.
Thank you, sir. Thank you for the guidance.
At present, actually, I am busy in my admission process in my college. So I will not give so much time for your attending the lectures. Okay. Thank you very much.
Thank you once again, sir.
So here we come to an end of the panel discussion.
Actually, you are asking for non-linear development.
Yes.
The end of learning. Already just learned. I think you have right like 90% or something like that. Yes. You have to say that diversify thinking. I don't want to hear.
Now I would request our Honorable Principal Sir, Dr. Braj Kishore Sinha, to come for the presidential address.
Thank you, Department of Geology. Thank you to all the guests, those who have been instrumental in coming to this point of this international workshop on the innovative approaches and recent advances in geology. Really, I am privileged to be here on this occasion, and the galaxy of scientists from IIT Kharagpur, Professor Parishnath Singh Roy, I just can see on the screen, Dr. Ganendra, Dr. P.K. Jain, and with me, Dr. Amlendu Sinha, who is here in this campus since last morning and blessing this occasion with his students and guiding the students of the PK in all the aspects, dimensions of geology. To know, to learn many of the things from the discourse that has been from yesterday. Many information that I had, I was not having earlier. Although I'm a man of zoology, student of zoology, had an idea of
Not able to hear.
Thank all of the people, those who have been instrumental in the success of this function and make me learn about the geology. Just now, I was rather, Dr. Amlendu Sinha was discussing with me that college is a place of learning. I do agree. It's a place of learning. You just learn things. But development of the skills, when you go into the actual job, there you learn things. How to work, how to finish your work. I was hearing to Dr. Sagar, what he was saying, time management, patience, hard work, all these things are very important. Because without hard work, without time management, without patience, you can't learn. Learning is in itself is a a process in which patience is very much required. You can remember, the students can remember when they were learning the alphabets of either Hindi or English. Time and again they were asked by their parents to write like this, move your hand like this. Many times they forget this one, but again they learn this one and they could learn finally. So studying in the college is something different than the actual when they go to the where they have to work. So there is a big gap over there. We all know this one. All the eminent scientists, those who are here in this workshop and have been sharing their experiences. So, but there is a lag. There is a lag. So all these things are there. Hold on. I think something. Continue.
It is okay. It is okay. Please go ahead.
Technical problems are going on, and I'm sorry for that one because the institution has just installed all these things, and the experiments are going on to have this much successful method in the college campus. So we will have to be we can't be at the level of IIT Kharagpur and all that, but we are trying our best to have the best technology on the campus, and we can reach to the students through online. And what I have seen from yesterday, that these students of the geology, they have been trying hard to meet the standards, and that is to this international level. Because you see, this is a learning process and they have learned a lot. Whether the technology is there or whether the geology is there. In both of the aspects they have been learning since yesterday. So I'm happy to learn all these things. One most important thing I would like to share with you people, especially for the students. Learning never stops. We also learn at this point of time. So learning never stops. You are undergraduate, you are doing your courses, that is of undergraduate. Then you will be going for the postgraduate, then for higher studies, PhD, postdoc, and so on and so forth. And the learning process will be there. This is one thing which is very much similar what we have the course of evolution from the Macaulay's system of education. Now there is a paradigm shift with the new education policy, and I hope when there will be no barrier of the faculties, when there will be no barrier of science, arts, commerce, and all that, anybody can learn anything. And this era which is coming in the future, that is the era that will be of skill. If you are having this skill, you will be excellent. You will excel in your field. So it is most important that you must have skill in yourself. That is most important. And how you acquire this skill, whether it is handling the instrument, whether it is oration, giving a lecture, or painting, drawing, anything. So there are n number of dimensions where you can excel. And if you are excellent in any of the field, job will not be limited for you. The sky is the limit then. So my dear students, especially, you have to learn this one from the galaxy of the scientists and professors, those who have contributed since yesterday to this workshop. And you might have learned many of the things. And I hope this whole of the workshop was a grand success, and you have learned a lot, not only here on this campus, but elsewhere. Those who are joined on this web or they are listening to this workshop, or they have presented their papers online, they all have learned, and this workshop has been a grand success. Thank you very much once again to all of the people, those who have contributed to this workshop directly, indirectly, and they have enlightened here students and elsewhere on the globe. Thank you very much. Thank you.
Thank you so much, sir. So now I would request Mr. Gaurav Kumar Ojha, Students Coordinator, to read out the report.
Thank you, Ananya. A very good afternoon to all. I am Gaurav Kumar Ojha. As the overall coordinator of the session and the workshop, I would like to provide a detailed report on all the wonderful events that took place over the last 2 days. I deem it a great honor and privilege to present detailed report. Report of 2 days international workshop on innovative approach and recent advances in geology. Organized by Geology Department, P.K. Roy Memorial College, Dhanbad, and Vinod Bihari Mahato Koilanchal University, Dhanbad. First and foremost, I will start with the aim of the workshop. The aim, this workshop aimed at presenting the result of innovative approach and recent advances in geology, mandate to assist students in our country in capacity building to perform context appropriate conformance. The workshop took place on 6 and 7 August 2021 at P.K. Roy Memorial College in Dhanbad. Day 1 in inaugural function, Dr. Anjani Kumar Srivastava, Vice Chancellor of Vinod Bihari Mahato Koilanchal University, inaugurated the Geological Museum and the Microscopic Lab. In his chief guest address, he emphasized on innovative approach in the field of geology. Dr. B.K. Sinha sir, Principal, P.K. Roy Memorial College, welcomed all the guests and participants and reflected on the progress of the workshop. Our guest list, Chief Guest, Dr. Anjani Kumar Srivastava, Vice Chancellor BBMKU, Special Guest, Professor P.N.S. Roy sir, Professor I.T. Kharagpur, Guest of Honor, Sri R.S. Saukar, Secretary Geological Society of India, Special Guest, Dr. Amalendu Sinha sir, Former Director, CSIR Simpa Dhanbad. Speaking on the occasion, our special guest, Amalendu Sinha sir, emphasized on how to teach new generation students in this highly technological world. After inaugural ceremony in session 1, there was a speaker session. First, the most prominent geologists of the world gave their address on this keynote speaker session. First, Professor P.N.S. Roy, Department of Geology, Geophysics, IIT Kharagpur, delivered a lecture on shale gas, a key to future energy. Second, Sri R.S. Saukar sir, Secretary, Geological Society of India, participated and spoke on the topic, a new approach to development of India's precious metals, public-private partnership model. Third, Mr. Bruce Rocha Renteria, exploration geologist at Captain Mining, Mexico, North America, spoke on the topic, recent advances in mineral exploration. Fourth, Dr. Benjamin Nikke, senior lecturer, University of Cameroon. His topic was influence of shear zone in AUPGE mineralization in the plutonic rocks. Fifth, Dr. Hayden Mott, CEO and Director, Geologize Limited, United Kingdom. His topic was saving geoscience, the importance of powerful public engagement. Sixth, Professor David De Bruyn, Adjunct Professor, Federal University of Pelotas, Brazil. He spoke on the topic of petrogenesis and metallogenesis of layered mafic, ultramafic complexes. 7th, Dr. Philippe Grandjean de Costa, research geologist, Geological Survey of Brazil. He spoke on the topic of 2.04 billion year gold platinum group elements bearing chromites of northeastern Brazil. Entire session was interactive session and speakers answered many queries raised by the participants. All the topics were really interesting. In the session 2 on 6th of August, there was oral presentation session. More than 60 participants, more than 60 students in the oral presentation that took part, and many have represented valuable research and interesting data and ideas. On 7th of August, first we had 4 speaker session. Session 3 was the speaker session. Our first speaker of 7th August, Professor Pradeep Kumar Jain, Professor Department of Geology, GMPGC, MCP University, Madhya Pradesh. He delivered lecture on the topic Morpho-Mathematical Investigation of Paneer River Basin District, Chhatarpur, Madhya Pradesh. Second was Dr. Ranjit Nayak, Assistant Professor Geology, AST University, Ethiopia. He delivered a lecture and presented on recent development in ophiolite studies and potential mineral resources. Dr. Sagar Kumar Swain, sir, Assistant Professor and HOD, Department of Geology, PK Roy Memorial College, basically he is our HOD, delivered the lecture on concept-based exploration versus detection-based exploration. He always in the favor of concept-based exploration. He always do advocacy of concept-based exploration. Our last keynote speaker was Dr. Devasis Mohanty, sir, scientist C, CSI NIST, Jorhat, Assam, spoke on the topic Earthquake, Science and Society. Again, all of the topics were really interesting and motivating towards research. Session 4, in session 4 we had poster presentation session. Many students from the Indian University participated in poster presentation and showed us quality research and ideas from their posters. More than 50 students participated in the event. In session 5, there was quiz competition. Every participant played well, but few were really fantastic. Almost 100 students participated in quiz competition and 10 students were selected in second round of quiz. In session 6, we had panel discussion. In panel discussion took place on career and job perspective in geology. There was professors and the scientists in the panel discussion. After that, our principal sir addressed us, and now I will say the number of participants who have registered in this event. Around 500 participants, and more than 500 participants participated in the workshop from various parts of India. And more than, I think, 100 university, students of 100 university have participated or registered in this workshop. Dr. Sagar sir, head of the Department Geology, convened the event. Many people joined as an audience through the YouTube live. All student coordinators worked hard to make this event a memorable success. The entire program was coordinated with the support of our principal sir, our HOD, Geology, PKRM College, and our university. Now I will conclude. A lot of faculty members provided the support required to make this event successful. This concludes the report on all the events that transpired over the last 2 days on this workshop. Thank you very much. This was the end of the report. Thank you.
Thank you for the report. As we are coming to the end of this workshop, it's time for the announcement of results. No doubt, every participant is a winner. As there is a saying, winning is not everything. but the effort to win is. Without further ado, I would like to announce the winners of the oral presentation session. Third prize goes to Ms. Lopa Mudra Biora. Next, second prize goes to Ms. Soumya Vyas.
Research scholar, Berutullah University.
First prize goes to Mr. Aditya Verma, Integrated PhD, IISER, Kolkata.
He is from PK Roy. He studied BSc from PK Roy. He is our alumni, basically. Aditya Verma. Please clap for him. Congratulations, Aditya sir. If you are listening me, congratulations from our department.
Next, we have the winners for poster presentation. Third prize goes to Mr. Suman Kumar Pandey, BSc in Geology from PK Roy Memorial College.
He is present here. Suman is very happy. Congratulations, Suman. Suman, come. This topic was really very interesting. Suman's topic. Biotechnology in mineral extraction and metal recovery. Yes, sir. Biotechnology in mineral extraction and metal recovery. Basically, he presented how geologist, but I have made it how low or low grade ores can be useful. How can we convert? How can we extract metals from low grade ore? Also, we can use microbes for say oil exploration. In oil exploration, in very economical way. Also, I have presented phytomining and phytoremediation.
Moving on next, second prize goes to Mr. Emmanuel Gain, PhD, Ravenshaw University. First prize goes to Mr. Sulendra Mato, MSc from IIT Bhubaneswar. Next, we have the winners for quiz competition. Third prize goes to Mr. Sinjan Roy, MSc, Presidency University. Second prize goes to Mr. Gaurav Kumar, PhD, IISER, Bhopal. First prize goes to Mr. Karthik M, MSc from BHU. Now I would like to present felicitation to our honorable guest. First, I would request our principal sir to give a memento to Dr. Amalendu Sinha. Now I would request Dr. Sagar Kumar Swain to give a memento to our principal sir. Now I would request our principal sir to give a memento to Dr. Sagar Kumar Swain.
Wonderful job. anniversary of this college.
Now we would like to present a memento, virtual memento, to all the professors who have joined us. Our special guest, Professor P.N.S. Roy. Now we would like to present a memento to Shri R.H. Saukar.
Secretary, Geological Society of India.
Now we would like to present a memento to our keynote speaker, Dr. Hayden Mott. Our next keynote speaker, Professor David Dept. We would like to present a memento to Dr. Philip Grandjean D'Acosta, our keynote speaker, research geologist. We would like to present memento to Professor Pradeep Kumar Jain. And then we will present it to Dr. Ranjit Nayak. Now we would like to present memento to Dr. Devashish D. Mohanty, our next keynote speaker. Now it's a memento for Dr. Benjamin Neach. Now I would like to request our HOD of Geology Department, Dr. Sagar Kumar Swain, to present the vote of thanks.
Actually, thank you, Ananya. Actually, this type of international events never ends. And this is the beginning. And hope we'll able to organize this type of international event in every year. And the theme of this international workshop was mainly on innovation and recent advances in geology. And this innovation comes only when, already I have told many times, then innovation comes only when that whenever we learn, explore and implement. That is what main theme of this international workshop. Then which will develop our imagination, curiosity and critical thinking also. Then finally, this is my vote of thanks. First of all, I would like to thank to our special guest, Dr. Ramlendu Sinha sir, former director, CSR Simpa Dhanbad, for sparing your valuable time with us. And from also you have, from your busy schedule also you have given so much time for us. Also, thank you, sir. And I'll also thank to our patron principal sir, Dr. V.K. Sinha sir, for sparing your valuable time with us. Thank you so much, sir. Thank you so much, sir. You have given us, sir, your. Then I'll thank to Professor P.N.S. Rai, sir. And on first day of the workshop, when I thought we'll organize this type of workshop, first I have invited Professor P.N.S. Rai, sir. That time he just replied, Sagar, carry on, keep it off. And sir, thank you for such an inspiration. Now this is just international level workshop, sir. Thank you so much, sir, for such type of inspiration from you. And next, I'll thank to R.H. Saukar, sir. And also, sir, from your busy schedule, also you have given so valuable time with us. And sir, as per your suggest also, will try to organize this type of international events in every year. Also, you have suggested this time also you can collaborate with the Geological Society of India. In collaboration with Geological Society of India, you can also organize this type of events. Like, sir, thank you for your suggestions. And also, sir, as a Geological Society of India is one of the best international journal. I think all these events, I think, sir, it will help and will publish in a good internationally, means all these events internationally also. And next, I'll thank to Dr. Hayden Mont, Director Geologists Limited UK. Sir, thank you for for sparing your valuable time with us. Then I'll thank to Dr. Felix Ganjan de Costa from Geological Survey of Brazil. Also, I have requested. Also, he has agreed to give a keynote speaker. Sir, thank you, sir. Then Professor David Dibron from Federal University Brazil. Thank you, sir. You have responded as soon. Means whenever I have just send you a message, just you have replied as soon, sir. Thank you, sir, for your such kind consideration, sir. Then I'll thank to Dr. Benjamin Niche, University of Yaoundé, from Cameroon. Thank you for your such a keynote speaker. Then I'll also thankful to Dr. Ranjit Naik, but due to network problem, I think he is not here. But thank you, Dr. Ranjit Naik, Assistant Professor from University of AST from Ethiopia. Then also I'll thankful to Professor Pradeep Kumar Jain, MCB University MP. Sir, you have given so much valuable time, sir. Thank you, sir, as a keynote speaker. Then I'll thankful to Dr. Devasis D. Mahanti from CSIR NAST Assam. Thank you, Dr. Devasis, for sparing your valuable time. And also, you are a jury member of this our oral and poster presentation. And thanks a lot. Then I'll thankful to all the faculties of these institutes, and without whom they have given so much valuable time with us. Also, I am thankful to all the faculties, and also I'll thankful to all the participants around the globe. Then also I'll thankful to all organizers, student coordinators, Gaurav, especially with his team, and for also oral presentation coordinator team, then poster presentation coordination team, then your quiz competition coordinator. Then thank you for all. I think from last 15 days also we have given trend to organizers as well as we have given trend to also participants. That should be the format of this oral presentation, and this should be the format of this poster presentation. And also we have such a nice session so that we have got trained. Our organizers have trained and also our participants have already trained. Thank you. Then lastly, I'll also thankful to all the non-teaching faculty, non-teaching staff of these institutes. Then also I'll thankful to electronic printing media and press. And again, I'll lastly again thank you for such a memorable international events that we have successfully conducted. Thank you all from my heart. Thank you. And now we'll conclude our events. Thank you all. Yes, sir. Yeah, we have international anthem.
हम लोग भी गा सकते हैं, वहां से भी बजा सकते हैं।
Now the program ends.
Formally, formal to end.
Formally program ends.